Good morning.
Morning.
I'm just the technical help here. So I promoted you to panelist. And are you going to be are you presenting?
Yes, I'll be the first presenter this morning at 10:30.
Okay. Okay.
So
Very
so
good.
how do I share the screen to show my presentation, my slides?
Okay. If you hover down bottom with your mouse, you'll see a green button that says share screen.
Okay.
You click that button and then it'll bring up a window, and then you can choose whatever application, or if you want to just use the entire desktop, you can do that as well. And then you hit share again, bottom right.
Okay.
Yep, I see you there.
Okay. So that's it.
That's it. I can see it's a horse of some sort, digital,
Yeah.
right?
Well, oh, wait a
Now,
minute.
if you're gonna be using multiple applications, you're gonna have to share all of
No, no,
them.
no. I'll just use one.
Okay.
I'm just trying to. Okay. Where is the? Okay. Oops. Huh. I am.
Yeah, it
I'm
looks like you're sharing just a picture, not like a JPEG.
Okay, that's not what I want to do. Okay,
Okay,
so
go up top and hit stop share.
okay.
Now go ahead and hit share screen again, and then you'll see. Well, do you have your the is it a PowerPoint presentation?
I have both PowerPoint and PDF. So does it matter?
Either or, whichever you prefer, but make sure both of them are already open,
Okay,
or whichever one you want to use is already open.
okay,
And then
okay,
once it's open, you'll click share screen, and then you'll choose that application.
okay. So I chase this and then I click on share.
Boom. Yep, I see it now. It's the PDF. Conclusions and open research areas. Research areas, excuse me.
Okay. Huh. But I don't see. I'm glad we are doing that because I am kind of.
Yep,
So
I'm
do you?
seeing you. You're scrolling through them just fine.
So are you seeing the first
Security
one?
games with insider threats.
Okay. Okay. So but
Now, are you on Mac or PC?
I'm on a Mac.
Okay, go ahead and if you want to hit the escape button, it might give you a better view of what you want. Did I
Yeah.
make it?
No.
No. So is it just you? Is it that you can't see anything except for what you're sharing?
Yeah.
Yeah, that's a common problem. Do you have multiple screens?
No.
Yeah. It does make it a little bit difficult, but we are seeing there should be like a green outline of that application of what's being shared.
Yeah. It says you are screen sharing.
Correct. So we're able to see all that. That's
Okay.
even better.
Okay. Oh, now I see myself.
Correct. Yeah, yeah. Your video wasn't on. I'm sorry.
Okay. Okay. That's good. So from this point on, I'll talk, and then when I change my slides, the change slide will reflect on everybody's screen.
Correct. I can even see your mouse pointer move around and everything. So
Okay.
yeah, it's like a live uh,
Okay.
preview. So okay,
Okay. So we are in business.
very good.
Thank you
You
very
can,
much.
if you're the first speaker, you can just keep it
Okay.
shared as of now, or if you want, you can stop the share and start it over again. I don't know what Dr. Barris would prefer. I don't think it really makes that much of a difference, to be honest.
Yeah. So I'll, just to make things simple, I'll just keep it as is.
Sounds good to me.
Okay. Very good.
All right. Just if you need anything, just speak up, and I'll be here.
Okay. Thank you
Okay.
very much.
You're welcome. Hi, Tal. How are you doing?
Hello, I'm an assistant. I'm here to help. Yeah, how are you doing?
I'm good, thanks. I will go ahead and promote you. I made you a panelist. I'll go ahead and promote you a co-host now.
Cool. And what should I do? Just have the session chair for organizing.
So if you click the participants, were you at the practice run last week?
Yes, yes, of course, yes.
Okay,
Yeah.
so if you click on the participants down bottom,
Mm-hmm.
and then you'll see on the side you have panelists and attendees.
Yeah, of course. And
Then you'll see the attendees list. There's nobody there now, but as people
right.
show up,
Mm-hmm.
you'll be able to hover over top of them, and if they're on the list to present, you'll
Mm-hmm.
click the more button, and
Mm-hmm.
then promote to panelist.
Okay. Yeah, I see that. Yeah.
So once and I'll be here as well for part of the webinar, and then one of my colleagues will be taking over for me
Mm-hmm.
around noon or so. But if you could just keep an eye on that and promote people as you see, and
Yes.
do you have the most updated list that John sent out last night?
Yes, yes, I have that. I have that. Yeah, no
Okay,
problem.
great,
Yeah, great.
great. So yeah, what I do is I print that out and just cross people off as I promote them to kind of keep
Mm-hmm.
track. But you can do it however you like.
Yeah, sure, for sure. So to sum up, every speakers when they come in, I just promote them as sort of the panelists, and then
Hmm.
they can do whatever they want, either present or
Correct.
answer questions. Okay, cool, got it.
And you can in the past they've been taking questions using the chat
Mm-hmm.
function,
Mm-hmm.
so you can keep an eye on that as well. But it seems to the whoever's running that particular session, it seems to take care of everything other than promoting the people to panelists.
Okay, I see.
So it's fairly easy as long as you just keep an eye on that attendees list.
Okay, sure. Yeah, no problem. So let's see.
So if you need anything, like I said, just speak up, or you can chat me directly either way. And then when I'm gone, it'll be the gentleman's name is Marty. Will be
Oh, Marty. Okay, I know him. Yeah,
okay.
because
Yep,
yeah,
he'll
yeah,
be
yeah.
coming in to fill in.
Attended the tutorial session, so I know you guys. Yeah. Thanks for help.
Gotcha.
Yeah, thanks for help. Yeah.
No problem at all. I'll be here if you need anything.
So let me see. So our chair is Kuan Yin, and we have 3 presenters. Yeah. Okay. Mm-hmm. And also, do I have to sort of remind the chair about the time limit, the sort of time slot?
Again, I'm not 100% sure because
Okay.
um, I feel as John
Yeah,
or
John sent me an email about it. So he says that the assistant should help organize, sort of remind.
okay, then if
About
that's what he said, yeah, he's.
okay.
I'm really just the technical support.
Okay.
So
No
as far
worries.
as the logistics, it's really up to him. So
Okay, no problem. But I
okay,
guess the session chair will take of it because
yeah,
it's
I believe that's the way it's been
yeah,
going. Yeah.
yeah.
All right. Thank you.
Thank you.
Good morning.
Morning. Welcome to this session. I am the assistant and I'm here to help. If you have any questions about the technical side, just chat to me and
Okay.
I'm ready to help.
Thank you. Thank you, Tal.
No problems. And
I don't see Kwanyan yet. Derya, good morning. Radha here.
Morning.
It looks like we're just missing Charles Camhoua for the first session.
See. Charles should be there. Let's see. Yeah, I am sending a note to John and Kwanyan. because Kuan Yin is missing here. Good morning, Tamer.
Good morning. Good morning, Derya. How are you?
Thanks. How are you?
Good, good. So rather, it's pretty early for you, but I guess that's fine. That's life.
Yeah, I was telling John yesterday that for some reason my sleep time seems to be West Coast and wake up time seems to be East Coast, 6 o'clock.
Yeah, yeah. Well,
not every day, but almost every day it seems to be.
You probably need more sleep, I would imagine.
I allocate a little bit of time in the afternoon for a nap.
It's very good. 40 minutes or less is my goal.
Yeah.
For the nap.
Yeah.
well, there was a few times I had to give talks at 2 a.m. and 4 a.m. our time. So
There, that's a whole
That's
different
brutal.
ball.
Yeah.
you have to adjust your sleeping hours.
Yeah. Hello, Murat.
Hey, good morning. Sorry, I was getting coffee.
Hi, Murat.
Good morning, Hocam. How are you?
Good, good. How is it? Are you teaching online?
I'm on sabbatical
Or you're on
officially
sabbatical?
at Berkeley, but I'm doing virtually.
I see. Well, that sounds
No one, everywhere is closed, so that's
Yeah.
Yeah, that's good. I'm going to try to reach. Oh, Kuan Yin is here. Okay. I was just
John
trying
here?
to send. John is not yet there. I was sending a mail to Kuan Yin and John, but Kuan Yin is there. So
That's what's important. Yeah.
Okay, so maybe we can get started. I think this is already 12:30. I think maybe John will join us at any minute from now. So our first speaker today is Derya Cansever. So he's from U.S. Army Research Office, and he is going to talk to us about security games with insider threats. This is one of the our invited talks. The purpose of invited talks is to introduce new topics to the audience in GAMESEC, and hopefully people would be interested in the topics and follow up with the research that the speaker will present. So I think Derya is here.
Yes, I am.
Great. So we can maybe we can. I think the screen is already here. I think we can full screen this presentation. Is this a slide?
This is PDF.
Oh, PDF.
So,
Okay. So is that's what you need, right? So
yeah. Is it?
This is fine. We can see the.
okay.
You can go to full screen mode, maybe.
Okay.
Down, further
down. Yeah, here.
Yes,
Okay.
right.
Yeah, go ahead.
Okay. So everybody can see it.
No, we lost it now.
Oh, we lost
When you
it
went
now.
to full screen. Maybe you can go back to how it was.
Yeah, maybe let's just go back to where it was. Okay, I think it's fine. Let's start
Okay.
with it.
Yes, sometimes it Max and Zoom don't always work well.
Mhm.
But anyways, I think it's visible enough.
Mhm.
Yes, yes.
Go ahead.
Okay, so good morning, and thank you, for coming to this session. I am Derya Cansever. I am a program manager of a multi-user network control at U.S. Army Research Office. As you know, U.S. Army Research Office funds fundamental research at universities, and there are several programs. We have like 40 of them, and mine is concerned with control of network systems, and it's multi-agent, meaning there are multiple controllers, and when those controllers have different objectives, you naturally have a game situation. So I am involved with games, but I am not the only program manager at ARO that cares about games. So there are, just a cybersecurity program, there's communications program, there are, machine learning program. So they all have their game theory related ingredients. And now I'm going to talk about some of the security games where insiders are present, and they can create a lot of challenging and interesting problems. So I will try to show some glimpse of it, some taste of it, and I think that's a fairly fertile and challenging research area. Okay, so let me talk about briefly advanced persistent threats. And I know I am preaching to the choir. Everybody is very familiar with APTs, but the reason I want to talk a bit about it is because that's a perfect setting for game theory. As we all know, APTs are launched by well-funded entities, and they are very persistent and pursuing their objectives, such as nation states or large crime syndicates. And they act in a stealthy way to avoid being detected. And then the consequences are big, just the staggering amount of losses. The estimate is like $6 trillion in 2021, which is huge. And if you also take into account the national security aspect of it, such as the ones that the army would care, then the cost is infinite. So that's something that we really should care. And attacks may occur without the defender's awareness for a long, long time to come. It's really hard to detect that you are under attack and you are incurring devastating losses. And so in a philosophical sense, game theory is an excellent abstraction to analyze those conflict of situation cases. And some of the arguments that I hear is that, I generally hear is that, well, it's a nice abstraction, but not everybody is rational, and you assume that, your opponent is rational. Well, when we talk about, nation state with infinite resources, just your opponent is rational. And another consideration is, is how do you define the objective function of your opponent? Well, if you know the objective, the goal of your opponent, then you can pretty much formulate your your game theory in a mathematical sense. So I think that's a very nice setting for a game theoretical approach. And given the problem, given the scale of the problem, so what is the best you can do? I think that's an opinion, but I believe that the best you can do as a defender is to create asymmetry of information. That's probably the most effective line of defense, because your opponent has virtual unlimited resources and manpower and computing power and intellectual power. So the way to deal with it is, you have some of your own private information, such as your actual architecture of the system that you are trying to protect. What are the configuration parameters, and then exploit it and to get your defense. And examples such as encryption, right? The key of encryption, that's your private information. So there is and your opponent does not. And even if your opponent knows that you are using AES-256 algorithm, without knowing the key itself, it is virtually infeasible unless they have some side channel attacks or inside information. And similarly, moving target defense, you change the parameters of your system. And I think that's similar to encryption because you change your system parameters, but if you do it in a periodic way, your opponent will figure it out, and then the effectiveness of your defense, will decrease. So perhaps you need an algorithm in implementing a moving target defense, such that it is how you do it, how you change your parameters is completely unpredictable. Perhaps you use an encryption algorithm to do that. So it is again akin to encryption, and then in an encryption situation you need a private information that you want to hide from your opponents. So the defenders should use the private information to create asymmetry, and then make the attack as difficult, as hard as possible. And then the way to invoke it in a game situation is to make it part of your strategy, part of the strategy of the defender. And that can be invoked in a few ways. One, you announce it. Hey, I'm using AES-256 encryption, deal with it. That's it. Or that your attacker are observing what you are doing. So you adjust your actions so as to announce effectively a strategy that you take into account in your future actions. So it is I think it's a Scalability game where you use signaling to effectively announce your strategy, and with the understanding that this particular strategy will also be taken into account in your development of defense. So we are talking a Scalability game between a defender which is the leader, and the attacker, which is the follower. And it is a follower because the follower, because the attacker looks at what the defender is going to do, what the strategy is. And I think one of the side benefits for the defender is that you can modulate your strategy with your private information so as to make it for the attacker very difficult to attack your system. I think that's the idea. That's an idea that you can use in designing effective defense policies of a cyber physical or an information technology system. So as we discussed, we are talking about a game, and we can formalize it at some level. And the ingredients are the following. So there's a common information known both to the attacker and the defender. And then there is the private information known to the defender only. And it's a random variable. And then the distribution of that random variable is known. I mean, if it's not known to, then they can also assume that it's uniformly distributed or Gaussian, or uniform is probably the worst case. So, and as they learn, they can further refine it. And the strategy of the defender is, whatever the information that it has, the common and the private, and then form a control based on that strategy. And the attacker strategy is a function of its information and new C, and the strategy that is already announced or observed or inferred by the attacker. So it's a mapping from the strategy space of the defender and the information that the defender has to the action space. And assume that there is a state X, which may also be driven by omega, the private information. And the defender and the attacker have their own payoff functions. And I used minimum because I'm a control guy, but you can also use maximum if we are talking about payoffs. So we have a stack over game, and with asymmetric information. And the defender, it optimizes its payoff, which is a function of the strategy of the leader that is announced. Oh, I'm sorry, that shouldn't be a omega, that is a typo. So I'm sorry, I screwed it up. So the attacker's objective is to optimize its objective function J sub A, which is a function of the defender's announced strategy that includes the omega P, which is a random variable. So, and then the attacker is optimizing the conditional expected value of this conditioned on whatever information that it has. So it is a stochastic optimization problem where there is a random variable that is unknown to the attacker. So let's talk about what the defender can do. Let's assume that WP has a finite support. And for each realization of this random variable, which represents the private information for the defender, there will be a different realization of the objective function of the attacker. So for each omega, here is that what happens to the objective function of the attacker. So you may have a different, so for each one, you have a different set of realization of that cost function. And I think one way to look at it, what should the defender do? The defender, I think, should make the life as miserable as possible for the attacker. And one way to do that is to maximize the regret of the attacker. So, and what do you mean by the regret? Is that, you know, the distance between the J star of A, the one with the red, which is the optimal solution based on the expectation of the attacker, and the realization. So it should make make sure that the strategy of the defender is such that whatever the omega, the realization of omega occurs happen to be, the incurred value of J sub A should be as further away from possible from that optimal solution that's computable. And all those possible solutions should be equally distant. So, you know, just you want to create a complete confusion for the defenders. And then a necessary condition for this is to attempt to maximize the entropy of that random variable. And the random variable is the one that is the expected value of the payoff function of the attackers, which includes, which is a function of that private information of the attackers or of the defenders. So, you know, make it as random, as unpredictable as possible. It also has the function of the increasing the entropy of this function not only pose an unfavorable optimization problem for the attacker, but it also makes it difficult for the attacker to compute it. So as we know from like a basic information theory, such as the one in Cover and Thomas' book, chapter 14, the expected value of the Kolmogorov complexity of a random sequence can be approximated by its Shannon entropy. So that, you know, when you maximize the entropy that's faced by the attackers, not only do you maximize the regret, but you also maximize the computational burden. So that, you know, that private information has a strategic importance on many aspects. But the compromising that private information by insiders can change the whole pictures. So I think the point I'm trying to raise is that private information is really, really important, but it is vulnerable because an insider, you know, can completely change the whole picture. And we have done some work when I was at ARL. It was part of the cyber CRA with Prasant Mohapatra and his students and his postdocs, and we try to model this environment where there is an insider. And so I'll briefly talk about it. It is we took a variation of the flip it game, you know, just where the defender and the attackers can take possession of the resources, and then the goal is to what is the best schedule to go and focus your resources to protect the system or to attack the system. and then there is a insider that can help the attacker, but it also wants to maximize its own profit, but doesn't want to be caught either. And then we formulated as a 3-level stackable game where the defender knows that there may be an insider, and then defender announces his strategy, and then the insider has its own cost function or objective function, which can be like get the payoff from the attacker at the same time. It works for the defender, so it cannot completely screw up the system, because its well-being depends on its salary, so that it cannot completely let the system be devastated. And then makes an offer to the attacker of, hey, here is the private information, and I want X dollars based on that. And then the attacker accepts or rejects. And then the defender takes into account all those considerations. And we have shown that, so as a function of the game parameters, the defender's payoff may decrease because of the insider, but for some combination of parameters of the game, insider may in fact help the defenders, or it can help the attacker, and it's a fairly complex and nonlinear game. Anyway, so I think that's a very interesting approach to model games with insider information. And so I think some of the open research areas that are related to this include, I believe, increasing the entropy of the external observable entities is a good strategy for the defenders. So I think that's an approach that can be exploited to design good defense strategies. And then design of policies that induce uncertainty for the attackers and also robust against actions of the insider. So that's two-edged sword. You want to create uncertainty, maximum uncertainty for the attackers, but you know that there is an insider, there may be an insider that negates that action. So you need to also take into account the objective function of the insider, so that your strategy is not only creates uncertainty, but it's also robust against what the insiders can do. And I believe there is a trade-off against between exploring, signaling, and exploiting. So you want to signal your strategy, but you want to do it in such a way that it creates uncertainty for the attacker, but at the same time, your strategy should also take into account what the insiders can do. And so I think this is a fairly fertile area of research. I believe I have just a couple of minutes for questions. Thank you.
All right, thanks for the talk. I think we have audience here. Whoever have questions, you can either type in the chat or speak up if you can.
Hi, Derya. This is John Barras.
Hi.
Maximizing entropy is a good idea, and it has been discussed a lot. Any ways that you can do that in a way that can be implemented?
I mean, I think so. So you start with your private information. It's your seed,
Right.
and I think like encryption algorithm is a perfect example.
Mm-hmm.
You know, just the entropy of your seed is pretty small, like 256 bits.
Right.
But the resulting entropy that the attacker faces, you know, the encrypted text, entropy is huge.
Yeah.
And similarly, you have the moving target defense. You know, just
but can the attacker do probing to try to minimize what you're doing?
So I mean, well, you so you want to do it in such a way that it's not learnable.
Well, that's why I asked the question. How much we understand about that?
But we don't. I mean, there's
Right.
open area of research.
Right. I agree. Yeah. Okay.
Yes.
Thank you. Yeah. No, that's what I wanted to say, and that you said it. Good. Thank you. Very nice talk. Thank you.
Thank you.
Thanks. If I have, can I make a comment on what was mentioned? So I think depending on the real setting, I think the entropy is much less compared to encryption, because in encryption, any bit changes completely change the encryption result. But in the other moving target defense, either the space could be limited, like people are using, for example, randomizing the starting point of a program in the memory layout. So of course you can start from arbitrary point, but the program has certain size. So the total entropy is limited. So what I'm saying is that encryption is a great example, but in real systems, it may be less uncertainty available to exploit.
Yeah, rather here, I also want to follow up Murat's good point. While even MTD or other setups, we may have an ideal measure of entropy for our mechanisms. When we go into system side, there are other constraints for performance and others which limit the space of parameters that we can choose and the range we can choose. So while yes, when we set up the initial problem, the space may look larger, the constraints may reduce us because as we have seen, we don't want to truncate the connections all of a sudden, and certain connections do need to continue, and there is a time for resynchronization. All these other additional components come in, especially with your statement that there may be an insider who may learn partial information. Even if you were to reboot or restart and reset the parameters internally, you cannot guarantee that the information that adversary has already learned is erasable. So that's one of the challenges with especially with the APT. How do we reason about randomization or any of the MTD techniques when the adversary has learned certain paths and certain internal privileges already? Yeah, so I agree that practical components make it a lot more challenging to think through.
Okay, yeah, I agree.
All right, thanks for the talk and discussions. Let's move, let's thank the speaker, and I'm plotting here. Let's thank the speaker, and I'll move to the next talk. So the next talk is going to be given by Ahmed Anwar and Charles Camhoua from US ARL. Are you here? Charles?
Yes, Kwanya, I'm here. Yes, I'm here.
Okay. So do you want to share your screen?
Yes.
Go ahead.
do not see the link to share.
Green
This
button.
not give me.
Charles, green button. Don't you see green button? Share screen.
There is a share screen
bottom.
button.
No. What is happening?
There's a share screen.
Should be at the bottom center of your screen when you hover with your mouse.
Maybe it's the setup, because in my setup here, I can. Ahmed, are you online? Can you share? I can send the slide to you, so you.
Yeah. So Charles, you can send the slides to me, and then I can.
Perfect.
I can go through the slides when you tell me to. So maybe in the meantime, maybe we can swap the presentation here if people don't mind. So maybe we can ask Murat to go ahead. I think hopefully there is nothing wrong with the sharing here. So let's go with the Murat's talk on attacking machine learning models for social good. And at the same time, Charles, you can send me your slides and I will look for it and I will monitor the slides for you.
Perfect.
Go ahead, Murat, go ahead.
Sorry. You can see my slides, correct, right?
Yes, perfect.
Yeah, they look good.
So thanks, John, and organizers for inviting me to give the talk. I will move to a little bit to privacy and adversarial machine learning aspect. So the main motivation for our work is that there is lots of papers and works out there that claim to infer something sensitive from your data. For example, there is some work out there that says that Facebook likes can expose your personality. I'll give some examples what that personality means. We read a work a couple of years ago claiming that your personal profile picture on social networks will your satisfaction with life, your sexual orientation, and also other things such as your mental health status. Apparently your tweets can reveal whether you are considering suicide. And of course, machine learning models can be used for things like credit scoring, recidivism, whether someone will reoffend or do predictions. So in all of these cases, the main issue is not that the data is collected in a privacy-preserving way, or it's the process is secure, but the machine learning model itself may cause fundamental problems with the privacy. And in some cases, fairness, especially if the model is biased in their decisions. So of course, there's one way of doing this thing is, again, I'm emphasizing this is not about how you build the model, but what the model does. Of course, the fairness of issues with how you build model, we can discuss more. The issue becomes how you could prevent these kind of things. And over the years, it's been known that, by the way, a few examples I promised, this paper claims that you are what you like. Apparently, if you like curly fries, you are slightly more likely to have a higher IQ on average. Charles, if you can mute yourself. If you are if you like iPod, apparently you are more dissatisfied with life. If you're into like C++ or programming, they claim that by using statistical analysis and machine learning models, you are more likely to be shy and reserved. We have no clue, but according to data, if you like In-N-Out Burger, you are more likely to have fewer friends on Facebook. So these are kind of statistical and machine learning analysis people try to throw in and use to maybe get some insights. And the scary thing is that there are some already happening where some companies look like using video analytics and social media analysis, etc., to filter out, for example, participants and applicants. So now the issue is what do we do? Of course, over the years, for those who are very familiar, it's been very obvious that machine learning models can be attacked. And these attacks are usually have two types. One is called evasion attacks or test time attacks, where you modify the instance or the given to the model, machine learning model, to make it have a wrong decision. Or there's the poisoning one, which is you add some fake information, malicious information to the training pipeline, so it makes error. Of course, down the road, all these attacks try to impact what a machine learning model could do. And the models usually can be random forest, standard logistic regression, or support vector machine, or more recently deep learning models. Of course, given this plethora of attacks, now the question that we want to answer is how we use these attacks for good to prevent someone making privacy sensitive inferences, or if there's unfairness in the data, if some subpopulation is unnecessarily denied credit, for example, by a machine learning model, can we attack the model to improve the performance? Of course, the main issue is that we wanted to choose these attacks. So in our case, we focused on evasion or test time attacks. And the reason is that an individual user can launch this attack to prevent prediction of private information. For example, you can change your profile information to look smarter, sexier, or whatever the machine learning model thinks. And of course, maybe you modify your application slightly so that you would get your credit. Of course, the impact of this is that it's individual to the local user, so we don't need to consider everyone else and don't need to impact the machine learning pipeline. And of course, this means that you only do these attacks at the test time, so you don't care about training. Of course, compared to regular attacks in the machine learning, one thing I would like to emphasize is that we want our attack to be ethical and legal. In the sense, if you are changing your credit application to prevent unfair bias to certain subpopulation, you don't want that to be considered a mortgage fraud, for example, or a credit fraud. So you may want to only modify certain subset of features in certain ways that the attack considered legal or ethical, compared to regular attacks. And of course, the cost function is also very important. As we talked about a few examples, there may be a cost, monetary cost even associated with modification in an ethical or legal way. And of course, as usual, we will have a target classifier that we wanted to change the decisions. For example, we wanted to hide the fact that hide our sexual orientation, for example. So that will be a classifier that will be predicting that. Therefore, our goal is really for the end user is how we can change our information so we get our target goal. But we wanted to make sure that the change is valid. Of course, what's valid, what's legal, what's ethical, etc., is really depending on the domain. And in this talk, I'm trying to give a few examples of where we applied this generic framework. Of course, this is very generic, and each application would require slight changes, and I will give you some examples of those changes. First example, remember I talked about Facebook, and people claim that they can analyze how your IQ based on your likes and so on. By the way, IQ prediction wasn't very accurate, so that's the reason we didn't attack it as much. But we consider this data set from Facebook, where there are 50,000 users and many, many likes. And we look at two classifiers for attack. One is like political view. Let's say for some reason you want to hide your political view. I know in US it's not a big deal, but imagine some parts around the world, this may be an issue that you want to hide it. And also sexual orientation. Again, this is just an example, but let's say you want to hide your sexual orientation from prediction from machine learning model. And we use this Facebook likes as features in predicting political view and so on. One technical detail is that you really need to consider this attack by doing dimension reduction. So we really reduced to 50,000 likes to 100 or so by doing some kind of SVD, and then look at the machine learning model. So I won't go into all the details, but we do many attacks. I will just focus on two today. One is what we call good feature attack. So for any target domain, find the likes, Facebook likes that are relevant for that target. For example, if assume you want to look like you are a Democrat, for let's say, then, or let's say you want to look like, you can flip this, obviously, and then certain likes is more associated with that class, so like liking Barack Obama, etc. And you can also think about bad feature attacks. So certain things such as supporting healthcare reform page may be more likely to be associated with a Republican. So you may want to hide those likes. And of course, our goal from the beginning is to make it practical and usable by end users. Of course, one attack is called mimicry attacks. So you may have no clue what's good, what's bad, but you know a person more likely to be classified in one way, and you may mimic that person. So we look at the results in very different settings. I'm just here talking about good features and bad feature attacks. And it turns out that if you add few, like if you have the 100 feature budget means that we can add at most 100 likes to a profile. We could we could increase the error in most classifiers to 80%. Of course, depending on the classifier and the attack type, error rates may change. Similarly, you could do bad feature attack, which means you delete some features that were associated with the class. So again, with few hundred features, you can have higher success rate. And actually, by combining good features, bad feature attacks, and a few other things, you can even increase this. Of course, when I say 200 likes and so on, in practice, you don't need that many. On average, when we say 100 like budget, it means at most 100 likes we add to a profile. But on average, 10, 15 was enough to achieve the goal, basically, for political view and so on. So this is an example of like a Facebook type setting where we add words or add likes and so on. The next thing we look into was like, what about classifiers? Again, remember, this was our early motivation of this work. We read some years ago, some psychologists claiming that they can predict someone's sexual orientation from pictures around 75 to 80% accuracy. And we were like, oh, how come this happened? Unfortunately, we couldn't rerun what they've done for IRB. Our IRB had some issues with it and we couldn't pass the IRB. But we did separate experiments to show that it's not really working well. So now, of course, the framework we mentioned changes. Now we have image, so we can arbitrarily add noise to the image. But of course, in order for this attack to be practical, where we add noise in the image may be restricted. So we have some certain restrictions. And of course, we wanted to maybe limit the amount of noise we add. So what I mean by this restrictions is that maybe you may not want to change your entire profile picture and so on and still look reasonable. We look at one example. In this example, we added glasses to the pictures, for example. By the way, as I mentioned, we have sexual orientation versions of it, but we couldn't publish or share results due to IRB concerns. So here I'm going to talk where we make people's genders classified differently. So here in our constraint, we just add the glasses, so you can hopefully print these kind of things on your glass, for example. We didn't look at the printing yet, but that's the constraint, what I mean. So we look under the setting, we look into something called Celeb A, which is a celebrity picture data set. It's public and available. And what we have done is that we use state-of-the-art deep learning models to classify someone's gender. So here, this is gender. And machine learning models are quite accurate, like with 95% accuracy, you could classify someone's gender. As I mentioned, we have done some experiments on the sexual orientation on real people, but we couldn't report that there it's much less. It's 60% actually. We couldn't replicate the studies, but again, we cannot publish. We choose random pictures that we can put glasses on. So it's randomly chosen, but the important thing is that if the people turn sideways, you cannot put the glasses on the picture. So we choose pictures that look straight. Among those, we choose these random things. And we put the glasses as a constraint. So we don't change the entire image. We just change the glass area. And we normalize these changes to -1 to 1. So that's the standard thing. So in every case we tried, by just putting a glass, we managed to flip the classifier. In other words, we can make a male to look female, to the classifier female to look male. Again, this is just an example of potential things, and this is applicable to other image-based classifications easily. So the end result would be something like this. So the classifier would classify the top picture as male, but once we put this lovely eyeglass, and it will classify it as female, for example, and you can switch these things easily. Again, this is just an example of this, so it's more likely to be useful for other things like sexual orientation things, and it works for that as well. So next, we look into scenarios where we cannot arbitrarily add or delete things or noise, but have features where we have some discrete attributes. For example, like whether you have a checking account or not. That information is a discrete thing, and adding random noise to it or some noise, numeric noise, doesn't make sense. So in this case, the framework changed slightly. So we need to really find the weight of each attribute change because different attributes, like adding for example, a new checking account may be slightly more costlier than adding whether you have a cell phone or not. So you need to subscribe to cell phone service, for example. So we have different weight for each attribute that we modify. And then since these are discretes, you change attribute K from I to J, so it has some certain cost per attribute. And here we assume that you have only changed some certain attributes. In other words, some attributes may be illegal to modify, and or you cannot modify them because of the many constraints. So only subset of attributes are modifiable in our setting. So what this means, for example, we look into something called German credit card data set. This is kind of older data set, but still used for analysis of fairness and also privacy, because it has this foreign worker category in it. And look like credits are more denied for the foreign workers, for example, in the data set. So here the machine learning model tries to predict whether credits is approved or denied. And if you try regular classifiers such as random forests, this is the best we could get in our paper. You can see a few more classifiers. You get around 76% accuracy. So you correctly predict 76% of the time. So what we looked into is that we look into attributes. This is just a hypothetical example. There are 15, 16 attributes, I believe, in the data set. We look into ones where we thought maybe it's okay to change, like purpose. Maybe instead of buying a new car, maybe buy an old car. Will that help you, for example? Or maybe increase the duration slightly or decrease the duration slightly. Will that help? So these are choices we thought it's okay for end user to modify, change, and so on. And of course, there are a few other things like phone number. Again, this data set is somewhat older, so they're having a phone would have impact, not big impact, but some impact, for example. So we chose attributes that may be okay to change. Of course, what the results show that is, for example, if you change the purpose, we look at the people, by the way, who 125 of them who were denied credit in the test data. And for example, if you change the purpose only, 20% more of those would get, 20% of those would now approve credit, for example. Duration, we look at the duration, like increasing slightly, decreasing slightly. there are a certain number of months you can may change 10% of the things. So these may be small changes by the end user that may reduce, as I mentioned, the unfairness of this classification, especially for this foreign worker subclass. Therefore, this may be used to improve the credit, those people getting credit. So of course, we look at different things. Of course, if you can change more of these attributes, you would have much more success rate. So if you change only 2, maybe 52% of those people will get the credit now. And if you can change up to 6, 90% would get the credit. Of course, changing 6 of them would have different costs and so on. And still, remember, we are not changing some of the attributes. So the people on those attributes may have some information that will prevent them from getting the credit anyway, whatever we do with these 6 attributes. But at least for the borderline cases or some cases that may be unfairly denied, this kind of changes look like helps. Of course, now we look into different cost functions. We weren't sure how much to get to a phone number, for example, cost or phone costs in that German those times. But we play with different things, like what if everything has equal cost, different costs, and so on. And we look into under these different cost functions, what would the examples will be flipped. And of course, if you have 100% budget, in other words, like you can change every feature and the cost associated with it, let's call it 100. And of course, as you get 100 and 100, in some cases you are getting closer that you can flip on the things, but to 90%. But of course, depending on the cost, the flip rates can go basically down to 60 and so on. So therefore, depending on the user and the cost associated with it, it would change. So therefore, understanding these costs realistically is important. So to summarize, although attacking machine learning models is bad in cybersecurity when you are doing intrusion detection or network classification, maybe one silver lining of that is we can use it to improve privacy and fairness, especially when machine learning models are used in ways that may hinder both. Of course, one big difference we want to emphasize is that we want to make it legal, ethical, and hopefully useful or easily usable by the end user. That's the reason, for example, we use test time attacks and we look at the costs. Of course, in this preliminary work and vision statement, we didn't really look into evolution. Now, of course, given these attacks, you may upgrade your thing. For example, you may remove the purpose from the decision making, for example, as a credit card company. So you may not want to care about the purpose, let's say. So how we would adapt to it. So that would be this game adaptation would be the next step, again, under ethical considerations. So I would stop here and be happy to answer any questions people may have.
All right. Thanks for Murat's talk. Let's see any questions from the audience.
Yes, Murat, thank you for excellent talk. Listening to you, I wonder if there could be an effort to have a baseline that some of these, let's say credit card or any other agencies, if they use the machine learning, they say, oh, we have run through this fairness ML module, and here is our performance. Is there a way for developing a benchmark so that
actually I'm involved in NSF as an entire Fair AI program. We have a small, we have a grant from there. So there is entire, like IBM has a Fair AI pipeline. So if and there are lots of things developed, like you can try to test it before you disclose your model. But the issue is that this puts the trust on the company and company to ethically behave.
Yeah.
So this is more like a scenario, put the power into end user, right? So imagine there's a company who's not behaving ethically or hiding their unethical behavior. So hopefully this is for those scenarios where the company doesn't follow the pipeline. Of course, if they are ethical, if they do this correctly, they may check that whether there's unfairness or not. And there are many tools on that. And we are developing some tools ourselves. Like one of the issues, this happens because the data set has imbalances. So we try to generate privacy preserving synthetic data to mitigate those. So there are, yes. So this is for unethical scenarios. The companies who be very ethical.
Yeah, they have their own profit versus social good trade-off that they optimize internally from. Yeah. Okay, thank you.
I have another question, Murat, that we know from very extensive studies in human perception that the order by which you ask questions in your scenario, the order by which you look at data influence the decision in the end. There are many psychological experiments that show that. And quite often by allowing the order to be in a specific way, you can get very weird examples of what people classify each other. So have you run into that?
So basically, we didn't look into human aspect to it. We just look into like the machine learning model itself. With a colleague, John Bagdash from Army Research Labs, we have a paper. We look into human behavior when they are given an explanation. And it turns out that humans have other issues there, like they may not understand the explanation or the machine learning model. So I think the interaction, especially, I know Army is looking into human and bot interaction, human in the loop settings. So there you need to address the issues that you raised. So we didn't look into human in the loop aspect. This is just totally automated based on machine learning, basically.
And it's based only on data, right? You don't use anything like you don't use anything like knowledge graphs or knowledge representation or any conditioning or prior knowledge or anything.
Exactly. And what I was trying to point out is that using human not necessarily improve the outcome. We have done some work where machine learning model and bring the human in it, it's not what does it. You need to be careful. Thank you.
Thank you.
Thank you very much. Thank you.
Okay. Thank you, Murat, for the talk, and let's move on to the next one. Next one would be, I think, Charles, it's working, right? We can see your slides here. Charles, are you here?
I will unmute him right now.
He's muted.
He is muted.
Okay, Charles, are you here?
Maybe he has to unmute himself.
Yeah, so I have asked him to unmute it.
Okay, I think he's unmuted.
He's unmuted, rather. I can see him.
Just now.
After I asked him, yeah.
Right. He went back.
Okay. I think, Charles, I think you're moving your slides, but we cannot hear you. Or can you hear us? Maybe we should send him a message or something. Charles, we cannot hear you. I think the audio system probably is not properly set up. So how can I send him a message?
We were able to hear him earlier, so.
No. Hear you.
He had phoned in previously, and now it looks like his computer is connected with the microphone, but so he may need to call back in. I'm not sure his setup.
Yeah.
Charles, if you can hear me, can you dial in like you did previously?
Hello?
Okay, good. Charles, good.
Oh, good. Finally.
I know.
Sorry.
Okay.
Because I have to change the computer, and finally that messed up the setup.
Good.
And I'm calling on my phone now. So thank you for your patience. Sorry for the mismatch. So I'm gonna start my talk now, and the talk is on game theory and attack graph for cyber deception, and we can see our battlefield from a long time ago, more than 700 years ago. You have no connected device, and coming to the projected battlefield 20 years from now, we can see a lot of sophistication, a lot of interconnection, interdependency, and a high level of complexity. So this will increase the attack surface, and by increasing this attack surface, that will open up a lot of potential vulnerability. So that's why we need to be innovative and using approach such as cyber deception. So why ARL is involved in this type of research? As you know, we are facing a lot of intelligent adversaries operating in a contested and congested environment, and we are subject to natural failure, selfish behavior, and adversaries that can launch very sophisticated attacks. Our network is also mobile, dynamic change of configuration, operating scenario, and we need a good scientific foundation to understand all those uncertainty. And we have chosen game theory to be doing that, to the quantitative reasoning power, the prediction power, and the best response that we can have from any potential adversary strategy. In a nutshell, we want everything to be automated because it will be beyond any human capability to, to understand everything here. Can you hear me just to make sure?
Yes.
Hello?
Yes, Charles, we can hear you.
Yes, perfect. Good. So, cyber deception, what are the main goals? The main goal will be to deflect an adversary from their goals, and disrupt the progress of the adversary on the kill chain, create a false sense of certainty. There's many ways to deny information. One way is just to randomize everything, like a moving target defense approach. The attacker know that they cannot learn, because the attack surface is changing faster than they can learn. And the second way is deception. In a deception, the attacker believes to have some knowledge when that in fact is false information. And in this case, even if the attacker come to realize that they may be deceived, they will have doubt about the information they are collecting. They will be wasting time to make sense of what they are collecting. Is this fake? Is this true? And they will be confused more or less. And if the attacker do not discover that they are being deceived, then they can be into a honeypot, into a trap basically, and perform there, and that performance will reveal, to us, to the defender, what the attacker are up to, what is the different technique and procedure they are using. Yes. So what are the main cause of cyber deception? And this is on a game theoretic setting. The cause of cyber deception for me will be the lack of knowledge, incomplete information. If you do not know who the attacker is the attacker in the system or not, you do not know his potential strategy, you do not know the attacker payoff, belief, you do not know anything about your vulnerability, all of that opens the way for deception. Yes, it can also be based on some limitation. For human can be like cognitive bias, for computer can be like limited computing power, memory, or limited time, so that you are forced to rely on some heuristic instead of computing the exact solution. That can be open to vulnerability that the attacker exploits. Imperfect monitoring, if you do not see, step by step what the attacker is doing, you open yourself to vulnerability. And partial observation, of course, because not knowing the state, make that you do not control the change in your environment. And any adversary can use any of those uncertainty to deceive you. Or you can also use this potential uncertainty to deceive your adversary. Basically, in a game of complete information, no uncertainty, perfect monitoring, it is very difficult to deceive. So what are the key principles? We do want our deception to be plausible. We want to lie, but in a way that makes sense. We need also to control the activity. Generally, low activity honeypots will be cheap to design, but also very cheap to detect. And the high activity will be more costly, but we can keep our deception persistent, multi-stage, and consistent, across a dynamic time scale. We want also the deception to be dynamic. We want to learn the attacker action, and adapt step by step to what the attacker is doing. We want to be unpredictable, and we want to be robust to counter deception because the attacker can have their own deception plan. So we want to be aware of that. So after that, I want to use this scenario as a motivation of some of the work we have done, on attack graph. And basically, we have a military network, and in such a network, we can have an attacker that penetrates a weak device, like a wearable device, and that attacker can be penetrating our network step by step until the command center and launch an attack on our military system. Yes, normally this is supposed to be active, but the animation is lost somehow. But good. Now, from this, we can have an attack graph when we understand in our network what are the potential vulnerability, and from the known vulnerability, we can build an attack graph, and that attack graph helps us to understand the interdependency between all types of vulnerability. We can also have to model the causal relationship between the different vulnerability and show all sequential steps that the attacker can take, from any entry point to potential target, and those vulnerability will depend on software, node, and any component we have in our network. Yes, we are interested in game on those attack graphs because they show an easy way to model cyber deception in a network setting. So as I say, we can have the deception at any node, and we can have that at the hardware, operating system, application user, but we are not looking at the user at this time, and the deception also can happen, on the graph, basically on the node. You can be adding fake node or hiding some critical node. You can be adding fake edge, or, and also hide some critical edge, or you can be changing some key parameter of the game, or just make a military network look like a civilian network. So deception is a broad topic, but we focus on the first two components: adding edge or node, or deleting edge or node, or deleting edge or node. Yes, good. So the key question we want to answer will be in three stages. We want to be proactive. So we look at the initial configuration before any attack happens, and we ask ourselves, how do we optimally allocate our decoy on the graph? And the decoy can be the edge or the node, but before the attack actually happens, what will be the optimum allocation? We also want that to be dynamic. That means when the attacker hit one of our decoy, we should be able, from that new information to reconfigure our decoy. And in the case that he hit the decoy, or we can partially monitor what the attacker is doing, how do we estimate the attacker intention, from the noisy observation we are having? So we have proposed here different type of game on different type of graph to address this general problem. So the first one is a literal movement that we have modeled on stochastic game. And in this model, you know, the state of the game that we have is the set of nodes that are currently infected, and the attacker can basically attack a new host or escalate his privilege from his current position, and the defender can open fake nodes, fake vulnerability, have honeypot allocated. Yes. And then when the attacker go to a standard host, that means a non-compromised host, the defender is not aware of the attacker move, but the attacker will be revealed, you know, when it hit a honeypot. So the defender will exactly know the position of the attacker at that time. Yes. So, and the defender will dynamically reallocate the honeypot here, depending on the move of the attacker that he can monitor. So here we use a one-sided partial or self-stochastic game. One-sided because what? We assume that the attacker knows the set of the game. Since the attacker is the one doing the compromising, you know, the compromising of nodes, the attacker can at least know what node he has already compromised. So making it one-sided. So then in such a game, we use a heuristic search value iteration, you know, to have a probability distribution over the possible states. We also apply a compact representation to reduce the number of states, given that in graph, the number of combinations quickly increase. So we do have a compact representation for that. And we have to deal with specific challenge, the fact that the heuristic search value iteration requires the convexity of the value function, you know, and we show that our compact representation preserve the convexity, and we had our novel approach based on the value backup operator. And we were able to have some good results, like at the scale of like 24 nodes, being able to solve the game, you know, in a short time compared to other traditional approach, and maximize the number of instances that can be solved in a limited time. Basically, for this graph, the results are shown, you know, for any node having connected to two nodes. That's the network topology. Every node is connected to two nodes, and one honeypot is allocated in the graph. You know, we do have even also good result when increasing the connectivity of the graph by having each node connected to 4 neighbors and having 3 honeypots allocated to the graph. Basically, those are logarithmic graphs, so you can see that our approach is better than others, like 2 orders of magnitude better, you know, and the results are documented in the 2 papers that you can see below. So this lateral movement is more targeted, and being more targeted, that means the attacker is choosing a specific path to go to a specific target. So presented in this conference, we extended this model, you know, to try to capture the case of epidemic propagation. That means, what if the propagation is more random, you know, and the goal of the attacker is just to compromise as quick as possible the maximum number of nodes in a graph, you know. So this result was already presented here at GAMESEC, so I can skip that, you know. And another line of work also presented here was to change the structure of the graph, you know, and looking at the directed acyclic graph, you know, and the approach here was a Stackelberg game, and one of the main takeaway here was that the utility decreased as the deceptive budget decreased because of budget constraints. This makes sense, but also as the size of the graph increased. So by increasing the number of nodes or by increasing the edge density, we have a decrease on the average defender utility. Yes, mostly because the attacker have more possibility, and the honeypot allocated have less chance to to catch the attacker. Yes. So in that same line, we presented here a game theoretic framework for software diversity. Basically, on a graph, what if we are diversifying the type of node that we are having, and we can show that diversifying the software enhance network security, prevent a full-scale zero-day attack, because you may not be aware of some specific zero-day. And if that zero-day attack and you have homogeneous nodes, that can easily propagate, to all the nodes in the network, but having different type of software will stop, the attacker if you have a more diverse network. And this can also, in the recognition stage, force the attacker to launch, to have more probe and facilitate the detection of those attackers. And basically also the diversity was not free, there was a trade-off there that was analyzed in the paper. And our results show here, that the attacker reward decreased as the number of available software type increase until it start to be expensive. And also the defender reward also increase here, increase. And too much diversity here do not always enhance the reward beyond certain numbers. So there's a type of marginal benefit here. So another line of work, I've looked into an hyper game formulation, and the hyper game basically differs from the standard game theoretic approach because what we are taking into account, the misperception that the player can have about the game. So you can be playing one game when the adversary is playing another type of game, So this is what hyper game tried to capture, and yes, and they were able to design an algorithm that compute deceptive sure winning strategy, yes, and with in which the defender can take action, deceptive, and lure the attacker into the decoy. Yes, so this is the sure winning strategy definition. We're able also to show that here. So future work in this direction is to consider multi-layer interaction, so multi-layer graph. So go across multiple layers, and this is important for multi-domain operation. And those two layers can be like the cyber layer and the physical layer, or can be any other type of configuration, but not just looking at interaction at one layer. So this now is just self-advertising of my recent book. I welcome your question at this time. Thank you for your attention.
Thanks for the very comprehensive talk. And we have 3 books here. One is Assured Cloud Computing, Blockchain, and Design of Secure Internet of Things. There's a large spectrum of work, also together with the game theory and the machine learning for cybersecurity. So any questions from the audience?
I may have a quick question. So Charles, in all of this work, you have the assumption on the attacker, like they cannot easily detect decoys and so on. So did you have like sensitivity analysis where what happens if the attacker can easily detect versus not easily? So imagine the changing probability of decoy detection. How does the defenses will change?
Yes, good, Murat. This is a good question. So for now, we have not considered this type of probability detection. We have assumed a capable defender who can, hide his decoy, and But we also admit that by interacting more with the decoy, it can be more like a long-term process. Because if the decoy from the first interaction can be detected, that will be more or less useless. You know, if you deploy some decoy that the attacker can quickly know that, you know, this is a decoy, that become more or less useless. But if at least it will take some time, you know, for the attacker to detect, that will be a good consideration into a model, like to see what if you are having in a game model a low interaction versus a high interaction type of honeypot. You know, as I highlighted here, for the low interaction, not that it's detected immediately, but after a short term, you know, that becomes detected. When for the high interaction, it may take, you know, several weeks or months, you know, for the attacker to detect that. So this will be a more realistic model, you know. Yes, I agree. Thank you for the good question, Murat. But this can open the door to a new research, you know, work. I'm not aware of any paper, you know, looking at this type of interaction. Yes, in other consideration, you know, there's the notion of smart attacker versus weak attacker, you know, and given supposing the possibility that a strong attacker can quickly detect, when a weak attacker will take a long time or will maybe never detect, you know, yes, we have ongoing work in that direction.
Thanks, Charles.
Well, thanks, Charles, for the question. Do we have other questions from the audience? We have still time for some discussions. Oh, there is one. So the question is in the chat box. The question was wondering what is the scalability performance of the deception strategies to large-scale network, such as Iobt, including massive agents?
Yes, so the first one I presented on partially observable was going now up to 24 nodes, you know, and we are trying to push that to a higher number of nodes, and basically combining machine learning approach, you know, to accelerate the solution of the game, you know. So have like a neural network learn all the possibility of the stochastic game, you know, find in a short time, you know, an approximate solution, you know, to this complicated game. Yes, but another type of work based on, you know, hyper game, you know, to find a sure winning strategy, you know, was able to scale like into hundreds of nodes, you know, yes, was able to scale into hundreds of nodes. So the scalability here depends on the specific approach, you know, on game theory, the specific assumption you are making, and the specific assumption you are making, not only about the graph, you know, also about the game model itself. Yes.
Great, thanks for the question and thanks for the answer. So do we have other thoughts from the audience? So maybe some people are typing. While people are typing, let me ask Charles this question. So you have this the book on the right-hand side on modeling and design of secure Internet of Things. So how is your approach can be connected with Internet of Things?
Yes. So the scenario that I show, the Iobt scenario, normally supposed to be dynamic, but for some reason that froze because, you know, I had to change the computer and quickly download, you know. So basically, this attack graph is a model on IoT, you know. So in this type of IoT network, even the lateral movement are presented and discussed was basically based on IoT consideration. Yes, but at one layer, again, only one layer type of attack graph, you know. Yes, basically the cyber layer, how is a cyber attack propagating? Yes, but, you know, the plan is to extend, you know, this line of work into more like not only the cyber, but the physical aspect, looking at the different nodes, you know, that are interacting and have like a two-layer optimization, two-layer type of optimization. Yes, so that will be, in my view, more challenging, but also more realistic. Yes. And the first part of this book, by the way, is focused on cyber deception. The first 7 chapters focus on cyber deception, on game theoretic modeling for cyber deception. Yes.
Okay, great. All right. I think despite the mishap during the technical part of this talk, so we have sound issues and slight issues, but good is that, okay, we are ending this session with the 3 talks on different topics. So maybe Radha, you can move on to the next session.
Thank you for your attention.
Thanks for the talk.
Maybe Charles can stop sharing. Kuan Yin, either you or Charles can stop sharing.
Charles is the sharing. So Charles, you can stop the sharing and.
Trying that. Let me see.
Okay, I activated it.
Okay, good.
Yeah,
great. Okay.
Good.
Yeah. Thank you, everyone. Now we move to the keynote by our distinguished speaker today. It's my great pleasure to introduce Nicole Newmeyer, who is the director of the NSA's Internet of Things integration. Nicole is responsible for guiding short-term and strategic direction, providing technical leadership to capability development teams, and providing technical recommendation to leadership focusing on integration of IoT across all of the NSA's missions. She is a graduate of the agency's Senior Technical Development Program focused on understanding the impact of Internet of Things technologies. Nicole is a co-chair for NSA's Women in Technology Group, a component of the Women's Employee Resources Group, and is an active advocate, leader, and mentor. Nicole has been recognized for her focus on mentoring and working to grow the next generation of technologists at NSA. With this, please join me welcoming our keynote speaker, Nicole. Nicole, it's all yours.
All right, thank you very much. Good afternoon. Thank you all for joining me today. As Radha said, I'm Nicole Newmeyer, and I'm the Technical Director for Internet of Things, IoT, at the National Security Agency. For those who aren't familiar, the National Security Agency is a component of both the US Department of Defense and the US intelligence community. NSA leads the US government in cryptology, both in its signals intelligence, or SIGINT, and cybersecurity missions, and is responsible for the security of national security systems. While I didn't have an opportunity to participate in the live sessions throughout this week, I have read a handful of the papers that were submitted to this conference. From an academic research perspective, I don't expect I'll say anything that you don't already know. But that's also not why I'm here, or why it's important to the NSA to engage in these conversations. The United States today faces very real, very grave national security threats. Extremism and international terrorism flourish in too many areas of the world, threatening our warfighters, our allies, and our homeland. Regional conflicts can have serious effects on US national interests. Hostile foreign governments and terrorists trade in or seek to acquire weapons of mass destruction and/or the materials to produce them. The newest threats we faced, and perhaps the fastest growing, are those in cyberspace. Cyber threats to the US national and economic security increase every year in frequency, scope, and severity of impact. Cyber criminals, hackers, and foreign adversaries are becoming more sophisticated and capable every day in their ability to use the internet for nefarious purposes. As a nation, we're dependent on the internet. We use it for everything. We communicate online, bank and shop online, and store much of our personal information there. In business, education, and government, we all count on having ready access to the internet and its many capabilities as we go about our daily routines. The internet opens up new worlds to all of its users. But while cyberspace offers great opportunities, it also comes with vulnerabilities. Our information networks and technology are constantly at risk from a variety of bad actors using a multitude of techniques: remote hacking intrusions, malware, spear phishing, and many other means of gaining access to networks and information. But that still doesn't speak to why I'm here. NSA cares about IoT because it's already changing the way we exist as humans. And we must work together to adapt to new challenges that emerge from this technology and others. While there are many different definitions of IoT, NSA views IoT as devices and technology ecosystems that didn't traditionally have connectivity, but now do. That includes everything from a connected toothbrush, to a wireless security camera, to a service animal with a two-way GPS tracker, to stoplights, to connected warfighters, and to a smart city. While I expect the answers from this audience would be a bit different than general audiences, I ask you to take a second and think about how many IoT devices you own personally. Most people outside of the technology and engineering community usually think they have within the 2 to 5 range. And it's not going to be a surprise to any of us, but 2 years ago, the average in the United States was already 5 devices. Excuse me. And that included everyone from a newborn baby to your elderly parent or grandparent who doesn't like using their cell phone. The overall average is certainly higher now, especially if you take into account the need to adjust that number, unless your newborn already has their own IoT devices, and some do. However, it isn't clear that some people realize that they even have that many IoT devices. Public surveys in 2019 regularly showed estimates of 300+ million IoT devices in the US. But those surveys, like every survey, were a result of inputs from randomized samples of the public. And if you compare that to the US's population of approximately 328 million, also in 2019, it illustrates the difference in perception of the IoT devices we own as compared to the actual numbers that exist and are connected to the internet. That also doesn't take into account the increased deployment and usage associated with the societal changes that have occurred this year as a result of the COVID-19 pandemic. As individuals, many people are likely aware of the IoT devices that they own, hopefully, whether that includes personal fitness devices, smart TVs, or other smart appliances. But the technology is so much broader than that, as everyone here knows. IoT is changing how every one of us interacts with the physical world, and we need to pay attention. Today, I'll barely scratch the surface of the breadth of IoT's impact to our society, to NSA's missions, and to privacy, but there's so much more to learn, and we all need to learn it together. Rapid technological change has brought opportunities and threats, broadened attack surfaces, and reduced barriers to entry for all levels of adversaries. This new era of competition plays out in cyberspace every day. Adversaries violating international norms, stealing personal identifiable information and intellectual property, destabilizing security systems, sowing discord and doubt in essential democratic processes like elections, and threatening the stability of everything from our critical infrastructure at home to the security of our soldiers, sailors, airmen, and Marines abroad. The ubiquity of IoT technologies will continue to drive this change. This shift is not something that NSA or any other single entity can fully address on its own. We need to work together to make a difference. As you've heard spread across presentations throughout this week, there are so many different facets to the challenge of protecting and securing IoT and other emerging technologies that everyone in this community brings a needed skill to the table. When we think about IoT and its impact on us as individuals or its impact on the world, we have to think about both the devices we realize we're interacting with, wearable fitness devices, contactless pay systems, smart appliances, and the devices that we don't have to physically interact with. Security cameras, air quality sensors, congestion sensors on transportation networks, motion sensors to minimize power consumption when an area is unoccupied. And while this may seem like second nature to us, those who aren't as familiar with the integrated nature of IoT technologies don't necessarily see that yet. As humans, we're conditioned to focus more on the devices we interact with traditionally. In many cases, that means losing sight of the increasing number and frequency of interactions with devices and ecosystems that we only interact with passively. Last year, I would have asked you to think about how many devices you came across on the way from your hotel room to this auditorium, if we were in a single location or in person. I would have asked you if, in riding the elevator down to the lobby, you had thought about the different communication systems each elevator car was connected to, from the facilities engineering systems to the emergency communication systems. Or if you stopped in the hotel lobby to grab breakfast or a coffee, whether the cafe had any contactless pay terminals. And that's not even touching the connectivity in any taxi or rideshare systems or public transport, including buses or subway, depending on the city you're in, that you interacted with either intentionally or unintentionally. Instead, this year, I ask you to think about the variety of different contact tracing applications that are being explored. Some relying on Bluetooth connectivity, others on RFID technology. There have even been a few personal wearable devices that have been considered for use as devices with the potential to measure personal medical information and detect infection, meaning general infection, not specifically COVID-19, earlier than you as an individual would otherwise notice. Some of these prototype capabilities are even being used in sports, amongst sports ecosystems to validate health of players and team participants. Separate from the technologies being explored to track and minimize viral spread, in some urban areas, there's been an explosion of delivery robot services and even robo-pets, or so we're told. We also can't ignore the increasing proliferation of IoT-focused malware and botnets. unfortunately affecting everything from medical devices in hospitals to the cable box in your neighbor's house. Next year, at the rate this technology is evolving, who knows where we'll be. Interactions with these evolving and emerging technologies, whether the broader global communities are aware of them or not, have significant implications to our privacy as individuals and to our businesses and government organizations. Together, these devices represent a growing attack surface for our nation's adversaries as they seek to penetrate our networks and systems, acquire sensitive information, or disrupt operations. Corporations and public businesses across the globe face the same challenges of protecting their intellectual property from everything from a script kiddie in their parents' basement, who at this point may have been there since very early this year, to state-sponsored activities focused on the acquisition of intellectual property. For NSA, one critical point is that national security systems use most of the same technologies as private sector systems, and as a result, share many of the same risks and vulnerabilities. For individuals, while many still aren't concerned, the privacy and security implications of the use of these technologies needs to be considered. Whether people realize it yet or not, from a privacy perspective, aggregated data is as much danger as an insecure device. The potential personal or other identifiable information, including pattern of life indicators, that could be generated or transmitted by these connected ecosystems is yet another example of the things that the technology community needs to take into consideration throughout the protocol and product life cycles and research into innovative solutions to protect and increase the cybersecurity posture in these technologies. Data is being generated at a greater volume and transmitted at a greater velocity than ever before. While every single data stream from every IoT device doesn't necessarily contain enough information to identify an individual or create opportunity for an adversary to draw conclusions about sensitive activities or information, the aggregate of the data streams often tells another story. One example of the potential of non-traditional data sources actually involves the Pentagon. Throughout the Civil War and earlier, it's said that certain US adversaries would watch for late night pizza deliveries to the Pentagon itself, sitting in the parking lot across the street in their cars. They were able to use that information to draw conclusions about upcoming activities or the schedule of operations, identifying which organizations were working at odd hours or when surges were about to happen. If we fast forward to this year and pretend that the Pentagon was actually a smart building and adversaries had some level of access to data streams from smart lighting systems, even if it were just on-off indicators or CO2 sensors or motion detectors in conference rooms, we have to ask ourselves, how much information would they be able to derive? If, on top of that, they were mapping GPS data from wearable personal fitness devices or other capabilities that support geolocation, like a few incidents, I believe, in 2017, what else could they determine? We can unfortunately point to individual examples of each of these things already, including the data generated by the use of the Strava fitness app that clearly identified military bases. With enough data, would it be possible to figure out which organizations were surging at what times? People are creatures of habit. Patterns are often easier to identify than we realize, as almost every single one of us fully understands based on a number of the papers that I read. With access to enough data, adversaries wouldn't even need to be physically present to see what was happening. And while the Pentagon is far from a smart building at this point, speaking of course of only the physical building and not any of its occupants, the same possibility exists across industry and our personal lives. Aggregate IoT data in both the volume that is being created today and even more so in the future presents privacy challenges and concerns that we all need to be aware of in both our roles across government, industry, and academia, as well as the implications on us as individuals. You may be wondering why there is so much concern from the national security community about a technology that has very quickly become commonplace across most of today's society. I'll offer a comparison that may help illustrate why it seems that safety and security measures across IoT technologies aren't yet as mature as any of us assume they should be or would like them to be. Does anyone remember in 1982, some research at Carnegie Mellon University? Researchers were frustrated that they had to walk across the building to get a soda, only then to find that the soda machines weren't always restocked. So they found a way to connect the vending machines to the internet so that they could check to see if there were cold sodas from their desks. At the time, this was an incredible innovation. Just like the slightly later activity where security researchers at MIT were tired of walking to the kitchenette only to find an empty coffee pot. So they found a way to stream a camera feed pointed at the offending coffee pot to a URL that was accessible from their desks. This is said to be the inspiration for one of the first webcams. Still didn't refill the coffee pot. 8 years later, in 1990, a connected toaster was demoed at the Iobt Internet Networking Show. And yet, like many other IoT devices, including very recent ones, the toaster still needed the human or a human to put the bread in and start the toasting process. The next year, a small robotic arm was added to the demo system to put the bread in the toaster. Human interaction was still needed, just to a slightly lesser degree. Comparing the evolution timeline of IoT to that of rail travel, it took over 100 years to go from the first steam engine to full transnational consumer rail. By that, I mean the transport of goods and leisure travel. That extended adoption timeframe was beneficial. It encompassed the evolution of regulations and administration and safety mechanisms. That isn't to imply that the safety regulations weren't event-driven. Many, if not most, of the safety regulations were driven by fairly serious accidents. Instead, I only point that out to say that there was enough time to implement widespread safety and security measures before rail technology became ubiquitous. We don't have that with IoT. The evolution and adoption of these technologies is happening faster than ever before. It's been driven by both functionality that makes tasks or lives easier, and by dramatic changes in human behavior due to events like the COVID-19 pandemic. While the use of IoT devices and technologies has been increasing significantly, those of us who work with these technologies still need to work together to champion greater awareness of some of the non-obvious implications to the rest of the world. Whether we like it or not, IoT cyber threats will only increase in complexity and impact as billions more IoT devices and ecosystems are connected, especially while many devices still have relatively little built-in security. And nation states and other hostile adversaries become better equipped in the use of cyber toolkits. Standardization should help with this, to include security in devices, but standards are still evolving, and the breadth of IoT technologies as everyone here fully understands, makes it less likely that full consolidation will happen in the near future. To be successful at scale, we need a widespread change in how we think about technology. As a society, we've been able to think about cybersecurity in the context of traditional information technology systems for too long. And we have to get everyone to start thinking about everything as a computer, no matter what the form factor. If you notice, I haven't mentioned a single solution yet. That's because there isn't just one. To address these challenges, we need to increase overall awareness, take advantage of our natural curiosity, and work together more than we ever have before. Some of the potential building blocks may have even been contained in the research that led to the papers and presentations at this conference. It's incumbent upon everyone, from standards bodies to manufacturers, to developers, to end consumers, to researchers, to take a step back and insist on the inclusion of cybersecurity functionalities and appropriate network protection mechanisms. That doesn't just mean thinking about cybersecurity threat during the initial product lifecycle, but also in how we interact with connected devices as consumers. We can't lose focus on the criticality of continually increasing security capabilities and functionality. Even consider devices that are already connected to our own networks. If you have devices that no longer receive security updates or aren't included in your overall network security approach, we're already accepting that risk, whether we realize it or not. And this entire subject is something that those of us who work in the community may be very familiar with. But we need to do our best to share this knowledge and these messages with everyone who isn't as familiar. Two examples in this space are smart refrigerators and smart lighting systems. How long do you, as a consumer, think a refrigerator is going to last if you purchase it new? Since I can't really get a show of hands, most people usually answer between 8 and 15 years. I err on the, we'll say, side of cheap. And ideally, I would like to keep a refrigerator until it dies. But a majority of smart refrigerator manufacturers have currently only committed to providing security and software updates for 1 to 3 years. While I'm sure the manufacturers would be more than happy if consumer behavior changed and everyone bought a new refrigerator at the end of that 3-year software support cycle, do you think that's going to happen in the near term or at all? But for those 5 to 14 years that smart refrigerator is still in use, but not receiving security updates, it's potentially increasing the risk of exploitation of our home networks. Connected lighting systems are a similar story. Most enterprise and government entities will buy large-scale enterprise lighting systems and only plan to replace individual components once the bulbs or ballasts die. I haven't yet spoken to a large enterprise who plans to upgrade their entire building lighting systems every few years. But the turnover in the connected lighting system market has been significant. Most of the smaller manufacturers, and even the large manufacturers that have been in the non-connected lighting business for a long time, have been focused on market share. As a result, they iterate through product offerings quickly and don't maintain support for older versions for very long. In one case, the manufacturer of one lighting system was evolving their product base so quickly that the entire product line was end of life before the product was delivered to one military customer. Now, I'm sure that had just as much to do with the purchasing process as it did with the manufacturer evolving their product. But that matters less than the fact that after 3 months, an entire smart lighting system would no longer receive security updates. Since an enterprise-grade smart lighting system is definitely something that needs to be connected to and monitored along with standard network technology, users and network owners either have to accept that there's a component of their network that just isn't going to receive security or software updates for most of its lifetime, or they have to find a way to use network segmentation and other more traditional network security techniques to limit the risk to the rest of their enterprise network. Or potentially the most unlikely, purchase a new lighting system. Now, that's only a decision that can be made if the individual or individuals responsible for the lighting system realize the implications of the product line support being shut off. Challenges like these are further exacerbated by the techniques that have historically been used to manage traditional information technology networks. It won't be surprising to probably any of you, but most enterprises don't have a clear picture of the IoT components connected into their enterprise networks. And often that blindness extends to operational technology components that have been integrated into their enterprise for years as well, including industrial control systems and SCADA components. While some basic cybersecurity techniques can help mitigate the potential threat surfaces introduced by this lack of awareness, we still need more to address the whole problem. Traditional cybersecurity best practices for situations like this include, but are not limited to, harden your network by using techniques such as use publicly available tools, such as Shodan, to discover internet accessible devices. Okay. Take corrective actions to eliminate or mitigate internet accessible connections immediately. Segment networks to protect from direct exposure to the internet. Implement secure network architectures using demilitarized zones, firewalls, jump servers, and/or one-way communication diodes. Ensure all communications to remote devices use a virtual private network with strong encryption, further secured with multi-factor authentication. Filter, excuse me. Filter network traffic to only allow IP addresses that are known to need access, and use geo-blocking where appropriate. Capture and review access logs from all of your systems. Encrypt network traffic. Prohibit the use of default passwords on all devices, including controllers, IoT, and operational technology equipment. Remove, disable, or rename any default system accounts wherever possible, especially those with elevated privileges or remote access. Enforce a strong password security policy. Require users to change passwords periodically where possible. All of those protection mechanisms make perfect sense if the type of network we are discussing is a traditional information technology network. But as soon as you start introducing emerging technologies or a significant amount of IoT technologies or even OT, just operational technologies, those mechanisms become, we'll say, exponentially less effective because the technology hasn't evolved to the point where administrators or users have that granular level of control, as much as we may wish it were different. The level of success of these measures depends on an accurate understanding of the devices connected to your network. as well as an ability to control those security settings. Unfortunately, not that this is going to surprise anyone, most enterprises not only don't have an accurate picture of what's connected to their networks, but they lack the ability to, at a scalable level, control the security functionality in those IoT devices, and regularly lack the ability to perform network monitoring to detect any emerging threat in protocols outside the traditional Ethernet, Wi-Fi, and sometimes, but very rarely, cellular spectrums. As a result, when we design cybersecurity and protection schemas for specific networks, we can't assume that any capabilities that we're developing will have insight into all of the IoT devices on any network, or will have the ability to enforce protections like encryption and password rules, because so many IoT technologies still just don't support that functionality. So we need to continue to think outside the box and focus our efforts on developing techniques to increase cybersecurity protections that can operate in uncertain environments with significant gaps in the data. That's just one of the reasons that research like what has been presented at this conference is so important. I'm not saying that this is going to be easy to address with the right approach. I'm saying the opposite. Cybersecurity is hard. IoT cybersecurity is even more difficult. You all know that. It isn't just about finding one vulnerability and taking advantage of it. It's about mitigating vulnerabilities and vulnerable architectures as best as possible, implementing a layered defense to protect your equities, and designing new approaches based on fields like game theory to identify and evolve protection techniques through innovative and analytically rigorous methods. It isn't something that's going to be resolved overnight. But as a global community, we need to focus on making incremental progress in cybersecurity and protection mechanisms across all IoT technologies. IoT technologies bring so many different opportunities for efficiencies and potential improvements to the world. The significant increase in the use of connected capabilities to support remote work over the past 7 months is just one example. As technologists, we all have to maintain awareness of the cybersecurity and many other challenges that come with the evolution of these technologies. And we need to work together to shape the technology into something that benefits everyone. One of the important topics that I mentioned, well, I used the word earlier, but I haven't said much about is privacy. Through the lens of the increase in remote collaboration so far this year, it's important for everyone, not only those of us who work in this space, to understand that the privacy risks aren't limited to individual compromised devices. Think about some of the news releases associated with the security gaps in some of the most widely used virtual collaboration software late this spring. The app or even end device the users were actually interacting with wasn't the vulnerable component. In this specific case, there were gaps in security measures implemented on the infrastructure. That's only one facet of the variety of things we need to think about. We can all benefit if we get to a point where normal users, not those of us who work with this every day, assume that if an IoT device senses something, either about an individual or about its environment, including even video or audio data the device collects, that the data is shared and analyzed by many parties. We need everyone to understand that this includes the device and network manufacturers who could be using this data to improve their own products. And also third parties the data may be shared with or even sold to for advertising purposes. As you are all aware, these information sharing agreements are often hidden in the end user license agreements for products. And we all know how many people thoroughly read those. There are some alarmists who would say that we likely won't see a systemic change in security and privacy until a catastrophe forces us to, like many of the security advancements in global railway systems. However, others could argue that while the current pandemic isn't an IoT catastrophe, the significant change in our global standard operating procedures could serve as that inflection point if we can all come together and help direct the change. There is so much that we can do to shape the evolution of these technologies. We need to continue to work together to do it successfully. Every single one of us sees many benefits from IoT, both now and in the future. But when it comes down to it, this technology is developing more rapidly than any other technology in the history of humankind. We have to approach it with unprecedented speed, awareness, and partnerships. We have the opportunity to shape the future of not only IoT, but how humans physically interact with technology together. I know it's a little early, but thank you for joining me today, and I'm happy to take any questions you may have at this point.
Nicole, thank you very much for a broader talk that touched starting from the distributed system, security, information leakage, side channel. Although you didn't use these words, that's where you started. Then you moved on to looking at the human component and unintended consequences. Then further moving on to topic that Murat's aspect talked about, this trade-off between the profit and the time and safety side. And hidden in that is the time scale and the fault tolerant components that some of the industry you have been involved, and also other DHS and others have been involved with the automotive side and the aviation side, where delegation of security to the organizations had created challenges, although researchers have been aware of the challenges, but have not been able to do much about it. The time scale and also other parameters dictated that. But then again, you came back to the distributed system from the topology mapping side, and also having the aspect of partitioning and managing security if possible. I have a set of questions, but I'm going to first let others ask the questions so that I don't jump into some of my own bias.
Can I go?
Yeah, please.
Thank you, Nicole. Very interesting topics. What I am hearing from industry, and hopefully we'll hear it in the next section as well, is the following problem. You are a communication provider. You give me a router. I take it home, and who knows what the heck I join to it, okay? Whatever devices I put up to it. And if I am a service provider, I can try to put some security, and we have a separation between network provider and service provider. So the service providers are trying to figure out what devices have you hooked up to your router to try to understand their vulnerabilities and therefore protect them. Now, that's a very, very difficult problem that I now have heard from at least 6 companies. And one of the issues is that due to the separation of network provision and service provision, they don't share data. So here's my question. There's actually 2 questions together. What is NSA recommending for situations like this that, as you said, becoming increasingly common? And B, the National Cybersecurity Center of Excellence, which you know about in the area, is creating a humongous database, which supposedly is going to be updated, and we are involved in it, to create a database of IoT devices together with their possible vulnerabilities, so that this can be used for defenses, for advising customers, and so on and so forth. Of course, this is just a limited attempt to try to address the problem. Any comments you may want to offer this audience? There are games techniques that one can apply to all these problems. Games between information sharing, non-information sharing, cooperation, non-cooperation. I don't want to go into that. I'm asking on the practical problem. You from NSA, what do you recommend we do about this problem?
So I don't expect this will surprise you at all. We wholeheartedly agree that that is going to continue to grow as an incredible challenge. And I don't believe that there is any single solution that's going to address the scope of the problem of the problems associated with distributed technology and shifting ownership of risk and vulnerability based on what networks and subnetworks these devices are connected to.
Can you force the establishment of some policies whereby if I buy an IoT device, the company that sells me the IoT device, all right, has testable installations on the device that will make it easy for a service provider to check what the heck you hooking. Because if I find what you hooking to me, I can of course go to my data vulnerability analysis and know what I have to face. And then I can put the adequate protection so to stop the attack, at least at the router, not getting into the network. Is that possible, or that's a very faulty vision of mine?
So while I suspect that it is completely technically possible, that is also outside the scope of the authorities NSA would have, because it's far enough away from our authority to protect national security systems that's not a discussion we would be able to lead or a requirement that we would be able to levy.
I'm happy to tell you that Vinton Cerf would disagree with you. He came to Maryland in the inaugural meeting we had for the Maryland Cybersecurity Center and gave a beautiful talk with the title, "How Can I Destroy Your Internet from Your Refrigerator?"
Well, I'm sure he has his view, but a couple of points that John brought up. First of all, from the GAMESEC community, Nicole, please agree, disagree with me. If I hear John, database creation, community has been aware of the fact that if you have the database, yes, your false alarm going to go down for that set of database information, and you're going to have complete misdirection for anything else that has not showed up. So that's why game theory and this framework is complete in the sense that if you have database, we incorporate, otherwise the model worries about both the misdirection and the false alarm for scenarios that we are not. So yes, MITRE database is good. And if you look at some of the work on APT that people using the MITRE database, I mean, unsurprisingly, they are getting 99 or 99.99. I'm thinking, why are they not getting 100% when they are looking at just the database part of the detection? But you go slightly away, the scheme collapses. So I think what Nicole is talking about, grounding, going back to, is information leakage. If you can characterize, you're going to be in good shape. And I don't think that is a problem that for heterogeneous systems, we understand what are all the side channels and how do we capture. Documenting can be good. That can be definitely useful, but only to the extent that it may be viable. I think the second one you asked, I mean, this is my opinion. Nicole, please disagree with me. Murat brought up this point that he can't allow the companies to be the verifiers of their well-behaving characteristics. I think that's the same thing goes here. If you go to the company and say, oh, company A, which is a service provider, is allowed to probe and check into whoever else is putting a system. What if they are later in a position to say, oh, now I'm going to build my device because I have monitored you, I understand your proprietary information, and now I'll be your competitor. Government is not going to be the one who is paying the lawsuit money for having enforced this probing ability. So I think there are other challenges which seems to be that we are not able to mitigate in these scenarios, right? I mean, I think it's ideal in ideal world where I see what you are connecting, and I don't have any financial shareholder motivation to compete with you after understanding what you are doing, because you are a small potato company bringing your devices to my network, so I can push you out eventually. So I think a lot of issue comes in with how much, I mean, we look at it from the modeling perspective, but we also typically have to be aware of the fact that you can't fully trust the companies to be self-policing. We have scenarios that have created challenges.
That's precisely why I'm asking for a stronger role of the government. I don't know if it's NSA or whatever, but there has to be regulation that says if you're going to sell me a device, you're going to have to allow me to find it. Otherwise, you cannot sell it. All I'm asking is for the device to be able to be found. I'm not asking what the device does, what information it's transferring. But if I'm going to give you a network and you have a large proportion of the components that I don't even know, how the heck you expect me to defend it?
Why can't the community do it so that later people?
Oh yeah, good luck right there. I mean,
exactly.
You know, community has failed years and years again. Okay, come on, all right.
So my take is this, you know, I work in a university, I don't work for the government. So at the same time, I think if government comes and says something, the next thing is that, oh, NSA wants to monitor me, that's why it's asking me to do that, right? So why can't the community get their act together to say, okay, we are going to do certain things and come to a third. I mean, I think putting it on the government makes it difficult for anything to move forward in terms of enforcing these kind of policies.
Well, just like there is regulation on food products, on anything that's sold in the market, there has to be a label, whether it's organic, whether it's what the amount of calories is on for each serving, and so on. So any product that is served a router, for example, in the market, should have a label of that sort.
Ideally,
saying what is the probability of vulnerability. So
and that's actually, well, I wouldn't say the probability of vulnerability, but a high-level labeling categorization is one of the solutions that's been explored. Part of the UK government is leading that that effort. I don't know if anyone is familiar with it, but some of the challenges they've had are differentiating between levels of confidence in different security functionality. So
yeah, thank you both, okay, especially Tamer, okay, because good, in Europe, both in Sweden and England, and actually I think in Germany, they started doing classification of IoT devices the same way as you did for cigarettes or for foods, okay? This is dangerous to your health, or be careful about this, etc., etc. So, but here, and I have nothing against the US government, I'm just saying, and maybe you can enlighten us, I have not seen such an effort. As I said, we are involved in a major effort from the National Cybersecurity Center to create a big database of IoT devices from all manufacturers we can find. And one of the indices is the possible vulnerabilities of each device. So if you are a network service provider or a customer that buys a device, you could go there and figure out, going back to Rada's comment about community, what are you doing? But I think we need something more systematic. I'm sorry for being so out on this topic, but I have witnessed it. I have tried to work with companies. We try to do packet classification and other techniques to find out what the heck you're connecting. Some of them work, some of them don't work. It's a problem. One computer scientist told me that his biggest fear is that we're implementing these massive distributed systems that we don't even know how they're going to behave.
We have been doing that for a long time with everything else, right?
Not exactly at this scale, rather, come on.
Internet is the same scale that has been there. Yes, now it's the next level. I think one of the challenges, I mean, yes, Tamer's statement is a valid one. If for the cigarette, you can easily label saying that smoking this tobacco will be bad. It's a global statement. How bad, how many times bad, all those details are not necessary. The interdependencies or what are the primitives modules that we had to characterize. If we can talk about some primitives, if we can understand that primitives that can be certified or guaranteed, then I think it makes sense. I mean, it's not that I don't think it's a good idea, but who should be doing it and how do we understand it? Because as all of you, including many of our collaborative researchers from the other labs know, one vulnerability, how it impacts the other one is a complex problem to characterize. You can't simply state the impact of this exposure on the next level of the system. How do I characterize it? So if we can do some primitive ones, maybe that is reasonable, but interconnected in the network, that may be tricky. Yeah.
Can I ask another question in a different direction? Have you heard of FIDO? F-I-D-O, Nicole?
Yes,
okay.
I have.
Right. So for those of you who may not have heard this, FIDO is a very exciting technology which there's actually a FIDO, F-I-D-O organization that has engulfed it, and there are many of the best known companies. And it allows us to use actually secure biometrics for authentication of users, and even biometrics from devices, not biometrics actually, patterns from devices like paths and other things to authenticate devices. And this, in my opinion, this is a technology that should play a very positive role in privacy. Any comments, Nicole, on that? Is that, I know you are restricted to what you want to say. I know you cannot say this is great or this is bad, but is that a good direction to go? Because it involves many people. It allows all these good technologies to be incorporated into this privacy and all that. Any thoughts from NSA on this topic that you can talk about?
So unfortunately, my personal perspective here is irrelevant. Our perspective would only be relating to the privacy implications to NSA personnel or other civil liberties and privacy implications of how we execute our missions. So from the broadest perspective, to what degree I understand the effort, they are following so far all of the approaches and traditional cybersecurity procedures that we would recommend. But whether it is good or bad or going in the right direction for personal or individual privacy is outside the scope of what NSA can comment on.
I see. Okay. I mean, what I see for many discussions, and I don't want to get political, but in terms of, making voting electronic and all that stuff, that some form of authentication of humans that approaches the face-to-face authentication, that's pretty strong, okay? Which, if you like the implication, it will involve some biometrics, is important. And you can read the Gartner report on, with a very nice title, Password Stink, and try to go to things beyond passwords. And you've seen many biometrics getting into iPads, iPhones, etc. I mean, you had the face recognition in computers and all that stuff. So some way of using these technologies in a groupy thing, right? Like FIDO claims to do, I think is very promising. And now, in terms of game theory, there are all kind of problems again here, okay? I mean, how much information I give, how much I don't give, how I collaborate, what do I do, where's the competition, okay? So for this audience, I mean, I know I'm opening up a whole big new areas, but that was the purpose of this conference. Have a look. Maybe Murat gave a nice talk in something a little bit unexpected into the data. There was another interesting talk yesterday from Nokia. They invited to talk about logs and all that stuff. I was just reading a report last night about the danger from your private data in terms of all kinds of stuff that were mentioned, and many more. So somehow we have to get into this, right? Humans are an important part of this, what we call, and you will hear in the next section, network immersed society. You're part of the network now. So whatever you do and whatever, and we are billions of us, and each one of us has several devices. Yes, Tamer. You were going to say something.
No, I wasn't going to say. Well, earlier I was going to ask the question whether there is any certification, any criterion for certification of security. I don't think there is, and that's one of the really serious problems that we are.
No, there was a group at NIST, right?
Any granularity on the on certification of security.
There was a group at NIST that was giving certification to devices for security. And that went away because about what, 8 years, 10 years ago, maybe Nicole remembers better, because people start realizing that once I start coupling devices together to a network, and I go to these distributed and composable systems, you cannot any longer do this simple verification. So you're right, perhaps we need to have a reconstitution of this process, okay? So as you said before, Tamer, to have at least some simple classification of IoT devices as with their vulnerabilities. I don't know what the characterization should be, but you should be able to know what the heck you're buying, what you bring into your home, where you should be connecting to, and more importantly, the service providers should know. My surprise was I heard it from 2 different groups of companies. Each pair had a network provider and a service provider. And they would not exchange data, so they could not solve the problem.
I want to add one more thing, since there was this deception discussion. Since IoT devices are much simpler, we found it, at least from different deception point of view, they are easy to create many deceptive IoT devices. So what we are trying is that, imagine I have 2 real devices, but I may easily create 10, 15 fake ones. Because the behavior of the IoT, like think about the example Nicole mentioned, like in Pentagon, there are some room lights if some attacker observes it. So you can easily create many, many fake lights and turning on off them randomly or with some certain behavior. So it will be much easier for attacker to figure out the real lights. But when you have a very complex system, we've solved that, like machine learning techniques can easily figure out the fake versus real. But when the system is much simplified, like the IoT, I think where the deception may really help. So I think this is a opportunity for cyber deception because of the relative simplicity of the domain.
I would completely agree. And one point I would offer on the certification and assessment points that were made earlier is that while it's nowhere near complete, we're exploring what options exist under the International Common Criteria effort through NSA's National Information Assurance Partnership construct, where protection profiles are written specific to categories of devices. And while I think everyone would agree that you can't have a single document that sets security standard for an IoT, we are the first step in what we were exploring was, are there security requirements we could define that would be focused on functions that would be verifiable in hardware if we built something such as a system on a chip protection profile, where manufacturers could either assess any processors they created or components that they created against that set of functionality to assert that the hardware controls exist to support the implementation of the security functionality that would be necessary in certain, for us, national security environments.
Yeah, if I may add to both John and Murat's components, So Tamer asked a question that, okay, can we do some primitive certification and things like that, which is great. Nicole's pointing out that some of the examples that you provided were essentially integrating these devices into cyber physical systems. And John, our community, everyone agrees that the physical system, I mean, this is great. Good people are here, so it's a good discussion. So we have these cyber systems, so cyber physical systems, and now we have these protocols that are there. And we all agree that when we integrate, unless everything is homogeneous, we have to understand the loose boundaries and the attack surfaces that are created. And clearly, attack surfaces are not going, vulnerabilities are not going to go down. So if we cannot characterize that part, and if the boundary intersection is open up for new research, I think it may be a little challenge to say that if individually we are certified, when we put together, suddenly we may be able to say a whole lot of thing to make ourselves feel comfortable. John, you are muted.
Oh, sorry.
Yeah.
You open up a whole can of worms that, you know, I opened up many times before, okay? And Nicole is going to certify that. Because the biggest open gap in security theory today, game theory or whatever, is we don't have a theory for composable security, okay? And that was the main reason why this office at NIST and so on and so forth was not, reduced, because they couldn't go from the security of the devices to the security of the composed network. There are some special cases, but this is still, and you guys at NSA create a special lab that I was interacting with Lockheed Martin, and now I can say to the public, and the reason for that lab was exactly to study composable security was because I think it was the second or third year of President Obama, they got into his smartphone. And basically they got into it by attacking the interfaces between software, which is obviously the common place to attack. So we have a lot of things to do in this networking security. And IoT, in my opinion, makes it even harder, because now the scalability is humongous, the opportunities are humongous, and who knows what's going to happen, okay? I think we need to move to the next section, brother, if you're okay.
Yes. We have more questions, but Nicole, I appreciate you taking the time and not necessarily pointing out here are the list of problems, but bringing the bigger theme and tying up back to distributed system. That is exactly at the core of everything that we started long time ago and we arrive at here. So thank you very much. And now we move to the next
Thank you, Nicole, very much. It was very interesting to hear your views. Yeah, thank you.
Yeah, thank you.
Okay, we move to the industry panel. We are very fortunate to have 4 very distinguished people from industry with very long experience. So they are Chris Christou, who is a vice president in the Booz Allen Hamilton Strategic Innovations Group, Mike Spanbauer from Juniper Networks and Juniper Security, Marina Totan from Nokia Bell Labs, where she leads the Network and Security Research Lab, and Stuart Wagner from Perspecta Labs, who has also very long experience both in defense and government. So let's just make a few words of what we discussed with the panelists. Basically, we want to talk about security and trust in this network immersed world that we have been discussing even during Nicole's presentation. What's the point is that we're now all part of the network. We are not sitting outside of the screen and the network is on the side. We are in it, either IoT to call it personal device or whatever. So some of the things I asked the panelists to discuss, they can discuss anything they want, is what do they see as their vision for the future networks with 5G, 6G, and all that stuff? The complete virtualization of networks via software-defined networks and network function virtualization. To what extent this goes to wireless? What is the implications of that to social networks, society, work, manufacturing, healthcare, and anything else they want to discuss? The plan is for each one of them to give us either a presentation with or without slides for about 8-10 minutes, and then we'll have a discussion at the end with everybody. So the first one I will ask to speak is Chris Christou from, are you on? You can
sure,
take
yeah. Yeah, no, let me,
Screen. Yeah.
yeah, let me share my screen for a second. Thank you, Dr. Barris, for this opportunity to brief you all. Do you see my screen?
Yes.
Okay, great. Yeah, like I mentioned, I'm very honored to be part of the panel discussion. Really look forward to a great interchange with you. And just to give you a little bit of background here at Booz Allen, we are getting into very much into 5G, building out 5G systems. We're starting to see a lot of opportunities from the federal government, the Defense Department in particular, but also on our commercial side, organizations really starting to take note of this, whether it be, especially from a smart manufacturing, smart warehousing perspective, you know, for example, in the automotive fields and elsewhere. So really from our perspective, where we're starting to see a lot of use cases pop up as our clients are trying to understand how best to leverage this technology. So everything from AR, VR is a big sort of killer app and presents some interesting aspects of you know, challenges for the network in terms of supporting high bandwidth like that, real-time monitoring, remote surgery, clinical review, especially in the telehealth field. So really trying to stress test how 5G with the ultra reliable, low latency and high bandwidth can support these types of use cases. We've also built some prototypes around 5G warehousing to really improve the efficiencies of locating goods and storing them in the warehouses. So definitely some exciting use cases, and I think they're only starting to proliferate now. But that also brings certain challenges, right? And of course, we also see the smart bases and smart cities being a big initiative, especially with some of the initiatives that some of the major vendors like Qualcomm and others have launched. This is sort of our reference standalone architecture, very similar to what you see in 3GPP, being deployed both by carriers, and we see private 5G opportunities out there. So we've sort of split it out between the operator, the mobile core, backhaul, edge cloud, and 5G RAN. With, of course, you know, I think this audience fully understands that there's some fundamental differences with 5G around, you know, the broader leverage of SDN and NFV, network slicing, the multi-access edge compute, which really presents an interesting paradigm with companies like AWS and Verizon and Microsoft and AT&T and others forming partnerships around those types of deployments. And then, of course, on the spectrum side is where a lot of the rubber hits the road with 5G, with the new spectrum availability, millimeter wave and others, massive MIMO, beamforming, and the full duplex capabilities. So we actually have released a report, which I quote, I had a picture of on the front page there around, you know, where are these potential new attack vectors? And some examples come at with the management network orchestration as a single point of failure. So if you get into that, you have really the brains of the network. Similarly, in a similar vein is software-defined networking that can enable degradation and defeat. So you really getting into that SDN controller, getting into the Mano systems, and being able to reconfigure the network so that you can let down the network's guard with the security controls, and as well as disrupt network flows. Also, with edge compute being much more proliferated, that just increases your attack surface. So really the same principles that you use to protect things in a centralized cloud environment like what Google and Microsoft and AWS offer really has to take into effect on those edge compute platforms where the form factor might be smaller, so the availability of security services might change, let's put it that way. And then also the virtualization of networks can increase the exposure to breach. So this lays out further some of these perspectives that we've covered, and each of them include, the method of attack, the impact that could be caused by the threat, and then the recommended mitigation. So some of those include evasion attack enables damage to industrial process devices. So that's really maybe not something quite as specific to 5G, but with those process devices, again, your attack surface only increases, and there's more of a threat against those smaller form factor. And then we've even identified everything from data theft across a network slice to compromised IoT, as well as SDN controller supply chain attack, which is especially interesting. Would love to hear from Juniper and others around, with the disaggregation of network devices, what we're seeing, our network engineers are increasingly becoming software developers, So in order to control the network, in order to monitor the network, it's automate everything. We're doing that not only for efficiency purposes, but because the network is getting more complex. And as a result, we need to automate to make the network more resilient. Well, I personally have staff who've stayed up at 3 in.the morning because there was a misconfiguration of a device. And so that's a real problem. And people are, with concepts like SRE, site reliability engineering and others, really just trying to introduce more software development. So that actually involves applying DevSecOps and others to the configuration of networks and how you develop that software. But likewise, that also means that you have to institute better DevSecOps software security techniques to protect that software that is now running the network. In particular, when there's this disaggregation, we have the network hardware potentially being from a different supplier than the software, or the software being homegrown. So I think, Dr. Barris, you mentioned again that interface point from a software perspective being something that we really have to take a look at. Then we've also identified other things like degrading of 5G signals, physical destruction of cellular base stations, that could be a threat in certain environments, and compromise in that mech, which also might not have the same types of physical security controls as you would at an Equinix data center that's located in Ashburn or elsewhere. So again, we do have a paper that we've studied, that we've released, that's available for consumption out there. Of course, it's written a little bit at a high level. We can only go into certain details around the threats, but I think it gives a taste of some of the things that we're looking at and the security architectures that we're developing in order to mitigate against those threats.
Thank you, Chris. Now we give the floor to Mike Spambauer from Juniper Networks.
Thank you. One moment.
Thank you.
Everyone see the title slide?
Yes, we do.
Wonderful. So thank you, Dr. Barris, and for having me on today. So I'm going to just share a little bit of the perspective that I bring. So I've been in technology industry for 25 years, and have helped deploy and test security technologies, infrastructure products, and so forth, for the better part of the last 10 to 15. Most recently at a company called NSS Labs, prior to joining Juniper just earlier this year. So what I do is I'm out with our customers in the field, talking with them about the problems that they're facing, and really, their concerns, both in regards to the tacticals as well as their strategic planning, because largely, most environments require at least 12 months, if not, 24, 36, and in some cases as long as 60 months to plan and prepare for, security architecture that is deployed out in a vast, array of technology points. So that's sort of the perspective I'm bringing here. And it's largely, I think, an echo of the direction that Juniper had been on. So, the fact is that a lot of the folks in the industry are saying that the perimeter is gone, it's dissolved. That's not, in fact, the case. We believe that the perimeter is at every connection. It's simply moved. It's no longer the four walls in which your campus is located or the data center. It isn't just those logical termination points that were at the edge of the routed environment. It's out at every application and every user's location. And so when you step back and kind of put this context as the lens through which you're looking at the world and your environment you're trying to secure, it shifts how you think about solving for the problem. And I think that this is key to setting up the next part, which is really where the world is heading, with more and more distributed architectures and apps. And as Mr. just mentioned, right, the fact is that as we begin to see real edge compute concepts materialize and manifest, we see more and more data living closer to the user, and therefore not in singular, databases, data lakes that are easier to put controls around. It sort of highlights the problem that we as an industry, face. And this requires a different think. It's a different approach as to how we've always secured the world, because gateways that we've depended on, right, the firewall, the ingress egress point, they won't be effective. It's just not feasible. You can't deploy enough of them. So, and really speaking to that point, right, the internet of so many things. So IoT is interesting, but when you step back and look at the number of both data types, applications, beyond just the devices alone, it's staggering for many to just sort of think about the grand scale. And listening to a portion of the last session as well, I think a number of those points were surfaced, and certainly the awareness of this issue has really sparked a number of great conversations. But the reality is as we move forward into this incredibly highly connected world of billions and billions and billions of devices that are used by billions of humans, we've compounded the problem and really introduced challenges that we as a human culture, as a world, have not had to face at a scale before. So when you compound that further with exactly what it was just shared, right? The 5G pieces, and the fact that over time we'll begin to see throughputs that exceed multi-gig up to potentially 10 gig on a per device basis. And you almost create a nightmare scenario from a security practitioner perspective in respect to how do you manage, how do you see all of these things? And I think to that point, right, this is all what we're seeing today, and we can extend that out. But every organization sees on average about one attack every 39 seconds, as well as that's coupled with the challenge of the cost of downtime and the cost of ransom impacts. Security professionals will tell you first and foremost that in most organizations, the top priority is uptime. It's resilience. If the service is offline, then security isn't going to be important. So how do you balance this demand? You must ensure uptime, availability, but also protect your organization and respect the privacy requirements within. And so, this year has seen a surge in attacks that frankly is, on its own scale. And we're going to continue to see this rise over time, where tumultuous scenarios, right, where macro conditions permit, right, adversaries or threat actors take advantage. So this is where the visibility across the entire environment, coupled with good intelligence and the ability to enforce, is key. And what we've been on the path to deliver, and what I believe personally is the approach that singular organizations can use to good effect, is pervasive sensor and visibility throughout the entire connected environment, not just mine, but also out into the cloud, and an enforcement orchestration mechanic that could take action on that intelligence, right? Information is only useful when I know it in context. Turned into actionable guidance becomes intelligence, and then being able to act on that autonomously is sort of an idyllic destination, right? Where the technology is able to self-protect and to self-heal. And so this is, largely solvable on an organization by organization basis. But let's, step back and think about, again, at a world level. It's one of those interesting academic discussions, which I think great minds are thinking about today. We certainly need to, as an industry, pause and consider how do we address this, on the scale of humanity, right? So, this was pulled in, but there's, method approach, but this is really just a graphic of how to do this and an iterative intelligence that learns from the threats that you've seen, right? So one of the pieces, and this is specific to our partnership, but I want to step back and just talk about it in a grand scope. There are methods to fingerprint IoT devices, and yes, there's an incredibly large number of them. but you can reasonably deterministically arrive at what that device is and what the anticipated behavior ought to be. And in so doing, apply some control mechanic so that you do not allow, for simple purposes, right, a camera on the finance network or card access, connections in the media lounge, right? There's things that you can separate. Much as has been best practice in the network world for 20+ years, and do so automatically now with the controls and orchestration mechanics we have. So this exists, but we need to accelerate and again expand the scope of what can be touched by these systems. So just really quick, the point is that at the end of the day, what we aspire to drive and to deliver is this concept of a threat-aware network. The network and security technologies and controls can't be divorced, right? They're not, it's not feasible to do so. And in this uber-connected 5G world where every device in your home or in your business could be potentially a gig or more of connected capability, if only one of those have a remote toolkit on them and has some method of egress, right, for video backup, for example, in the context of a camera, then these are the scenarios and the problems that we need to look to solve for as an industry. And I think that there are approaches that do have considerable validity and frankly merit in that approach. So that's really I just wanted to surface the prospect of the possible and really also tease up the fact that I think we've still got work to do as an industry to deliver on this. But I'm excited about the fact that we are making the right investments and moving in the right direction. Oh, you're muted, John.
So thank you very much, Mike, for the views from Juniper. And now we turn the floor to Marina Totan from Nokia Bell Labs. Marina, you have the floor.
Yeah, I'm just going to try to share my screen.
Yes.
Okay. Are you able to see it?
Yes.
Okay, good.
Yes, we can see the slides. Thank you.
Good. Okay. So thanks, John, again for inviting me. And both my panelists ahead gave a pretty good overview of all the challenges of what we will encounter. So that makes my job a little bit easier so we can get to the discussion part faster. So, but let me just quickly go over basically to summarize what was described by the other two panelists is, we've so far been living in a world of best effort consumer internet, right? Our present realities, we have a centralized cloud, we have a bunch of consumers and enterprises on one side, and we have a somewhat monolithic infrastructure, right? Maybe multiple vendors, but still in terms of how the solutions and how we build out the solutions is still pretty much vendor specific in some senses. But as we go towards 5G, there is a real emerging reality where we're trying to move the digital fabric, like it was mentioned in the previous discussion, towards the edges of the network. And part of the reason is in order to be able to support a lot more of the real-time services and trying to get more into the enterprise applications, things for, I think the first panelist was talking about in terms of factory automation and a whole bunch of other more real-time needs that are there. And so you go all the way to the prem cloud and to the edge cloud. So the compute functions are moving closer and closer to the edges of the network. And that's actually creating an architectural shift with this introduction of the edge cloud. And in addition to that, we're also having different kinds of access technologies that are coming in. So you're also starting to see a convergence of wireline and wireless in the backhaul space, especially. So you're starting to see it's no longer people talking about, yes, I have a wireline connection or I have a wireless service. It's going to be, I have connectivity. It doesn't matter what the connectivity is running on, whether it is a wireline network or a wireless network, it should be seamless to the end user. And that's the way in which the world is evolving. And this increased focus on the enterprise consumer is actually what makes the security problem even more critical, because it's not just the home environment, it's actually critical operations within factories and within enterprise segments that are going to be a prime space for the application of 5G technologies. Now, one key aspect of 5G is also the disaggregation and also the softwareization of how we want to build network applications. Now, you all saw the slides with the AWS and Google and all of the other cloud players coming in as well. It's probably the single most exciting time to be in networking since the time the internet was born, because I think there's a lot of players, a lot of possibility. And I think if you look at how much has the internet really evolved in terms of being able to provide services to people, it's still only connectivity. Right? You can't really ask much more of that service other than just connectivity today. But if you really want to open up the network for real innovation to happen, again, I'm from Bell Labs, so this is a Bell Labs-based presentation, so I'm allowed to dream. So my dream is that we will be able to open up the network platform in a way that we will be able to allow consumers to be able to then use open APIs to the network to be able to then actually say, define the service that they would like to be able to provision, possibly even over a federated environment across multiple CSPs. We're already talking about slicing, so why not extend the slice with better negotiations for better guarantees across CSPs? So all of this programmability that we want to enable through these APIs and that allows to abstract the network complexity and truly make it an innovation engine for how we want to expose, because you do see that already, right? Today we see Twilio, for example, creating platforms for messaging. There's another one called MessageBird that's trying to find a way to be able to use all kinds of messaging platforms towards any particular service. You don't worry about which platform you use to talk to people. If you want to create that level of flexibility for the network, then you truly have created an age where the network becomes one of those things increasing the productivity of how your human population can innovate, right? It will become a fundamental technology that would impact the GDP of your country, because that's the way you will start to innovate on the network. So when you start thinking about this, what is at the basis of all this? You really are talking about disaggregation, softwareization, multiple vendors, no more monolithic stuff, services that are now need to be orchestrated real time across multiple platforms that exist between different vendors and different even operators. So putting all of these things together, what I see is happening is, and look at the kinds of applications we want to put together as well. It could be something entertainment and fun, like a stadium service, but it could be also autonomous cars. We're involved in a project in France in preparation towards some of the games that are happening there. We're looking at working with Renault, for example, creating a fleet of car management so that you can do better transportation. And that will be using 5G networks in a big way to be able to create the maximum capacity of how you can transport people on the roadways. So the problem with all of these things is that the impact of a security incident now is far greater than what we ever envisioned in the past. And it also becomes safety critical. That actually is the bigger concern, because a lot of enterprises are going to now start depending on the network to provide that safety measures as well. So it's no longer just safety in this isolated, SCADA fenced kind of network. It's going to be really on something that is a distributed network across the edge cloud and the central cloud. So given that, I just want to say what I see are some of the major, and this kind of got covered a little bit in the previous session that I attended at the tail end of, is the hyper diversification of end devices and networks, right? You have a wide range of devices, and these devices are of all kinds and shapes. They have memory, compute power variations, that you can't have a one size fits all solution towards how you address security. You have to be cognizant about which device is the consumer or the enterprise using to be able to set up that service, because you're responsible to provide a security SLA, but at the same time, you also want the flexibility to have the user define what device they want to use, and that's the way you can allow that innovation to happen. So how do we address security challenges in that wide range of devices that are there? And we talked about the infrastructure. Also the market, the increasing number of solution providers. This is in addition to your traditional telco vendors. So what we used to do in the past is we would have GSMA or different kinds of organizations that would actually put together how you would provide security. So 3GPP is trying to define slicing security, for example. But a lot of the main players are not really there in those in those standards fora. So where do we get them also to appreciate and understand the security challenges as they start to serve telco-like services towards the end consumer? And there is no holistic solution, and they're operating on wide ranges of platforms and operating models as well. And also the technology, it's probably the fastest, in the last few years, there's been the fastest increase in the way the technology has evolved, going to cloud native. From VNFs were there just a few years ago, and now we're all about cloud native and microservices, and it's a vast change in technology, and it's at varying degrees of maturity. Your legacy networks haven't yet had a chance to even adapt the VNF models, and you're already into cloud native. So you have a real challenge. I mean, it's very interesting to see when you go into, I think the colleague from Juniper said that, when you go into the real operational network, you start to see how much of legacy still exists in some of these networks. And so being able to have a solution that actually implements across these varying maturity levels is also a big issue that we'll be facing. Another important component is open source, and open source, because a lot of us are seeing in the telco space that it's very important to innovate fast and innovate cheap. So if you want to fast develop and be cheap about how you do it, you are going to leverage tons of open source code as part of your development. But there's no guarantee what the source of that open source code is. There's some misconceptions that open means secure. There's also how exactly do you mandate security within the open source environment. These are all very hotly debated topics, and I think there needs to be a little bit of like a rigor put into how you would take components from open source and incorporate that into building up solutions if you want to meet a particular security posture. And this is just a summary of the kinds of, if you were going to put together an end-to-end 5G solution in any operator environment, you're going to be faced with, vendor-specific microservices that come out. You may have the operator themselves having developed some microservices and functions. You have open source implementations. So even if any one vendor, when they go out to give a solution, they're faced with a mix of these different technologies with every different operator you contend with, because each one has done a different strategy on how they are actually going to implement 5G. So 5G is not like all those standardized. The implementation of 5G is many different ways. So it's not like one size you can have the perfect solution. So it's a really very critical problem. And just to illustrate the complexity, here's the landscape of industry initiatives and where we are with open source. The old model has been for every physical layer or every layer of the network, you sort of have a standards body that governs the ORAN, the IETF, the broadband forum, you have all of those things, but they are narrowly focused on their particular technology. They're going to look at security at their particular technology. But when we talk about services or really creating that innovative network platform, it's really end-to-end. There are gaps that come in when you start to put these things together. So there has to be bodies that actually try to address what happens when you define services on top of this disaggregated infrastructure. And ONAP tried to some extent address some of these problems. This is an industry open source consortium that is there. Again, even in the open source, there are also domain-specific kind of open source solutions as well. So I think as recently as August of this year, there was an open source security foundation that was set up probably to address some of these concerns that we're seeing within the open source community. And that's a good way to start putting some structure around this problem. So I think what I want to say is to kind of start the discussion around is the 5G is an important area. We are actually starting to build the 5G security testbed jointly with NIST. It should get started in the beginning of next year. And one of the because the instantiations of 5G could be all kinds of flavors, these testbeds become fundamental in terms of really doing that continuous threat monitoring and trying to understand how do you really keep yourself, keep up basically with the attackers so that you can actually know what the solutions have to be. So you really need to have that ability to place honeypots or how, create the environment for being able to create those new scenarios that would make the network vulnerable. We also have some efforts to find a way to communicate between operators, for example, or between enterprise segments about the incidence of a 5G attack. So we've been putting together a framework that would allow operators to use the same language, the same description about a particular attack and what happens. Because typically what you find is there's one attack in one operator, pretty much within a week or two, another operator somewhere else in the world has had a very similar attack. So in the 5G space, it's going to be even harder to keep track of these problems because of the diversity we just discussed. So having a framework on how you describe these attacks so that more people can learn from it and kind of catalog it so that they don't get caught by the same attack that was already seen once before in a different different geographical region or different part of the network. So I would say my focus has been on the 3 key technical challenges as to dealing with supply chain, all the way from devices to cloud infrastructures, both from the trust levels as well as maintaining the integrity of those platforms, virtualization, the variety of underlying execution environments that you have to deal with. And it actually is one of the newest network threat surface that has shown up. But with virtualization, we're talking about DevOps. I think somebody else mentioned this. Operators would like you to develop code and send it out into their production network as soon as possible. But that kind of continuous software updates is kind of getting in, you really need a way to be able to assess and make sure that the software delivery is actually following the security processes as well. So you're not sending something into the production network before you've validated its security solution posture. Open source, again, openness. What is openness? Do we get good quality code is definitely one question, but also the other part of it is how do we assess the security? Do we need to create certain mechanisms that would assess the trust or the integrity of the people contributing code, or is the code once contributed, does it maintain its integrity before you include it as part of your solution or your software development process? Those are all open questions to be addressed and tools to be developed on how you pull together solutions. And of course, the software supply chain. So these are kind of the broad strokes of the different new problems and an exciting bunch of research areas that can open up for academics and industry to work on in the area of 5G security.
Thank you, Marina. So we now give the floor to Stu Wagner from Perspecta Labs. Stu, you have the floor.
Thank you, John. Can you hear me?
Yes.
Great. So thank you for the opportunity to participate here. One of the, and by the way, I have no slides, I'll just be speaking. So one of the themes of this panel is trust, which of course can mean many things. And I'll define trust here in terms of resilience and reliability of network communication. And fortunately, all 3 previous panelists here, I think, have well motivated the nature of the problem and the need for highly reliable networks. If the reliability is inadequate, people will not trust the services and they won't use them. So my first point is, unfortunately, what I am seeing today in nearly all venues is that we have a lot of work to do to meet the reliability goals that 5G and related services are envisioning and requiring. We regularly experience network outages, some of which can persist for hours or more. So to be more specific, I think to stimulate future progress here from a research standpoint, I'd like to cite in my time 4 specific challenges for us to consider as a research community. And these challenges just reflect what I see as shortcomings as I monitor the various research conferences. So first of all, we talk a lot about cyber attacks and security. Think beyond cyber attacks. And I think Chris made this point earlier. most of the network service outages that we suffer are not due to cyber criminals. They're due to non-malicious failures like network misconfigurations, firmware bugs, failed line cards, and so on. We need to take time to understand how they manifest, the nature of the failures, and what we might be able to do to identify them and rectify them more quickly. Because if we can't do that, all the cybersecurity in the world probably isn't going to move the ball down the field too much. So along those lines, there was a question in the chat about the use of AI and machine learning. So my second challenge is, how can we use AI and machine learning to automate and to accelerate the diagnosis of failures and attacks? This is quite often today very human intensive. It relies greatly on human intuition, and that's why it takes so much time to repair these problems. Also, think hard if you're considering the use of, say, machine learning, and in particular, I think contextual reasoning could play a big role here. Think hard about attacks that are relatively easy to carry out and are certainly plausible, but that we don't hear much about in the press. So much is being said today about DDoS, distributed denial of service attacks, and they tend to be fairly obvious when they occur, but think about attacks that could be extraordinarily damaging, but aren't really very obvious. So for example, a few years ago in a government network, there was a firmware bug in a load balancing system that basically ground TCP to a halt because it caused just enormous packet reordering. And it took several days to isolate and repair that problem. And I would claim that it's not difficult for some bad guy in the supply chain to replicate exactly what that problem was and to use it as an attack. So how can we use AI, machine learning, and related techniques to isolate and mitigate failures and attacks of that nature much more quickly than is possible in today's technology? A third challenge is consider, and this has again been mentioned before, but I think in other contexts, consider the potential use and the impacts of distributed computing. So this could include the edge computing, the MEC paradigm that's a part of 5G, but could also include more pervasive deployments of programmable switches and routers in the network. And I'm not talking here about SDN. I'm talking about a more extensively distributed computing infrastructure as is possible today with P4-enabled switches that can perform very sophisticated operations directly in the data plane at line speeds. I think and again, this refers back to some of the previous talks that described edge computing. A disconnect that I see is that in most cases, the industry is regarding, say, multi-access edge computing as being a cool method of service provisioning. So how can we deliver new services with very low latency, for example? And yes, it's good for that, but I challenge us to think of it instead as an opportunity to instantiate new and better service assurance mechanisms inside the network, cyber defenses, monitoring, and mitigation techniques directly in the network as opposed to relying on, say, some network operations center. Distributed computing can open up new attack possibilities, as the previous speakers have highlighted. That issue is being tackled separately. DARPA's Ops 5G program, for example, is addressing it head on. But it continues to be a problem. But the question I'm posing here is, what is the value of distributed solutions to service assurance, and what could we accomplish with it from a service assurance standpoint? I think that's the challenge. And then finally, fourth, we need better ways of tackling the complexity of today's network systems. So today, networks have become just enormously complex in terms of their technologies, in terms of their feature interactions, and the underlying business models, where, for example, a retail service provider could be relying on transport services from a half a dozen other service providers who are then themselves relying on other service providers and so on. And so if something breaks, who's responsible and how do you fix it? The complexity there introduces, I think, huge new failure modes and also vulnerabilities that can be very difficult to diagnose in current art. So just to plant a thought in your heads here to close. For example, something I thought about lately is look at what Netflix does with its simian approach to anti-fragility, the old Taleb idea of anti-fragile systems. Netflix deliberately breaks stuff to see what the reaction is, what the fingerprints are, and how quickly they can respond to it. So, you know, us humans, as smart as we all are, as smart as we all think we think we know exactly what's going to happen when something breaks, but quite often that turns out to be false. So could we follow this example more broadly in the very complex networks that we have today to learn more about their failure modes, how the failures manifest, who and what will be affected, and therefore what types of techniques and steps we need to have in store to be able to deal with those problems. So with that, I'll close, and I guess we can all take questions.
Thank you all very much. This was very informative and exciting. I will open the floor to questions. Does anybody have any questions? We already have a discussion on the chat about AI and machine learning. We probably can say more about that. Any other questions from anybody? Like I said, either if you are on the panelist, you can unmute yourself and speak. If you are on the attendees, raise your hands and we will unmute you and then we can speak. Okay, so then I have a question to all of you. Okay, so all of you talked about automation. Actually, you have to go beyond automation in my mind. You have to automate the automation, which we call systems engineering here in Maryland. But anyway, an important part of the automation, and I know all four of you and your work, etc., is network slicing, which means that by software, I can dynamically allocate subnetworks, both in terms of topology and services to satisfy certain needs of the customers. And now, as you all mentioned, this opens up all kinds of problems with respect to security, safety, reliability, and so on and so forth. So since we like game theory here, because game theory is a fundamental methodology to understand trade-offs and all kinds of other issues between individual users or groups of users, where are we in terms of automating network slicing? And please, when you answer it, try to take a view from the point of view of security, safety, and reliability. Anyone from the four of you?
I'll start. As far as automating network slicing, I think in terms of operationalizing network slicing, it's still, coming to fruition, right? We're just now getting the first standalone 5G networks deployed. And at least from what we've seen, it's still in industry itself and what's commercially available, still emerging. So I think it'll be interesting. I'd love to hear from Juniper or from Marina from Bell Labs as far as what they're seeing. But I do think that will have to come together with the network slicing. You can't do anything today without automation, right? And so a notion of applying the same automation techniques to how you create those network slices will be really important. In some ways, you're doing part of network slicing in networks today with MPLS VPNs and others, but it's really the extension to the MEC and the RAN that is a big paradigm shift. But love to get other observations from Mike or Marina.
So yes, I agree. Without automation, slicing doesn't happen. But John, to your question about are we looking at security as well? In some of our proof of concepts, and you've seen our lab where we have been able to automate slices, what we are doing is, in addition to orchestrating a slice, also starting to orchestrate the security itself. Like, what are the security attributes that you want to have in the different domains of the network as you cut across? But are the operators deploying it today? Like Chris mentioned, 5G SA slicing is still being trialed. It's not yet in the full market deployment. But if you're looking at something like a pre-5G slicing, you could do that over today's 4G networks with some slight extensions. We're doing some of those trials. But in those actual production trials, we're still only testing out the slicing component for the performance KPIs, less about security KPIs, because we don't really have a full definition of what those security requirements or how do you characterize those KPIs for security is not yet ready. So, but in terms of the lab prototypes, we have been doing security orchestration over slice.
and I'll just chime in as well, right? Largely the places that I've seen deployed and used have been early trials and pre-production validation. As far as where interests lie, at scale deployments are still early because of the dependence on all of your peers, right? And so we have a fairly capable offer, and because the security capabilities in Juniper run within Junos, so all the platforms are running the same. They're one and the same, and the policy controls and instantiation can be administered and deployed through an orchestrated manner, and really follow the slice as it's being provisioned and set up. So we're in a decent spot given where the market is. But I think to the question that's been asked, where the world is heading, right? Certainly, we're excited about the prospect. I mean, the potential of being able to deliver this frees providers from the fairly heavy lift, hardware dependence models that they've been using before to leverage and expand their own business models. Because at the end, the intent is to provide more agility to a sector that had been largely really deeply rooted, and in respect to the fragility or the resilience discussion point that we've had, I think this is an exciting prospect for many, simply because time to new service provision can be shortened into weeks or days, ideally, right? And that's where the fascinating part for me is, just a geek, I get excited about this stuff when you think about how long it has taken in the past to provision.
So one thing I'd like to ask is, with these APIs, it just fascinating to me, the extension to the RAN, the extension to the MEC, and even maybe externally where you could have more of that self-service self-service provisioning that we see in the cloud. And that's a paradigm shift for public networks, and not sure what you guys' thoughts are around that, whether that'll come to fruition or not, and what the security implications are.
Please.
Go ahead, Mike.
I was just going to say that I think it's inevitable, right? I think that, frankly, whether we're ready for it or not, I think that demand and consumption needs will drive that requirement, and bids will be awarded to those whom purport to deliver and to do so in a production manner. Whether we're ready for it is a different question. So it's that mirror when you look at the question you'd asked about our capabilities at scale to protect, and to do so with the confidence that we know what we're effectively securing. Now we get into the more interesting AI and ML components that we touched on a moment ago, which is to respond and react at adversarial speed, the speed of a threat, right? This is not something you can depend on humans to effectively manage and control. It's just not possible. They're already moving faster than most orgs can, and where breaches today can occur in the space of a couple of hours at scale, we're talking minutes or seconds potentially as these performance needs increase. And so introducing slicing, automated provisioning, the fact that I can punch a hole in your network via your orchestration and slicing mechanic, exfiltrate it all, and then shut it, it'll leave no footprint. How are you going to investigate? So there's some fairly big questions that we need to think through as an incident responder, as a security expert, beyond the technology, to recognize that as a process, as a motion, as an industry, there are some really fantastic opportunities, but some big problems to suitably address. And so I'm optimistic, but lots of things in motion.
So I think there are some countries that are already starting to do that, right? Like Asia Pac countries are starting to define sort of a security rubric for 5G on how they think that these different components could be orchestrated. But one other thing that, as much as yes, the complexity is high, but there's also more flexibility in how you can customize security. So it may not be kind of a blanket security for all 5G services. You could now customize your security for the type of service, and the flexibility that slicing and virtualization provides you is that customization. So you don't have to have 100% ironclad security for every service. You can now customize it based upon the requirements of the service. And that's actually the interesting flexible dimension that slicing adds, in addition to the complexity that 5G brings. I feel it's the trade-off. Yeah.
Except that I have no, I have to intervene here because I've seen to almost everything that all 4 of your companies do, and here is the gap I see. Okay, so a lot of people in this group, in this audience you're talking to, have looked at trust, dynamic trust, trust propagation, mistrust propagation, game theory for that, and the trade-offs between allocation of resources and trust, different trusts, and between security and performance, right? So where in network slicing, the dynamic slicing, where do you actually use dynamic trust mechanisms to allocate some form of security metric or value to the resources you're going to use? And then this is taken into consideration in the slicing. And where do you actually do trade-offs between how much security, as you mentioned, Marina, you can or should have versus other things? Like if I'm serving automated driving, timing is extremely important. Sure, security is important, but if I give it too late, it's going to be a crash. So where is that happening in the network slicing formalism? Because I'm not trying to criticize you guys. I just have not seen it.
No, it's a good question because that's actually one of the things that we're doing with security orchestration, right? Because you take a security attribute and you start to split the security requirements for that particular service to the different parts of the network, right? Yeah. And so in terms of like now, when you say, how do I expect a certain level of trust? So to some extent, we do have some examples in the lab that I could show you where when you have a service that is actually in a factory that is running a robot, that's the example that we have running in the lab, you want to actually continuously monitor how the robot is behaving. And you also want to actually monitor the integrity of the control system on that robot, right? So you can actually use root of trust based attestation, or you can run almost attestation at different levels that you want through the entire stack of software as well as the hardware. And again, it depends upon what is the posture for security you're trying to orchestrate. But of course, there's an expectation now that the elements or constituents of this network support those capabilities to be able to do that. And that requires more of a consensus building in the industry because you're limited by what you are putting into your network.
Yeah, and Dr. Barris, I have to add that you bring up an excellent point. This is a requirement that we're seeing more and more, which is how do I engineer my traffic so that it traverses networks that I more trust, especially given some of the issues revolving 5G at the moment, right? So how do we engineer that traffic to route over more highly trusted networks? And at the same time, what we've really looked at, we've seen requirements at it, and we are actively doing it is, okay, that's fine when you're going into network slicing use cases, but also what if ultimately you don't trust anything and you set up zero trust architectures over those 5G networks? So that's a very significant application of that.
And there's a number of interesting implications, but I think the only 2 pieces that I'll also add is, to the question you'd asked, John, about when or where, at instantiation, and you'd have a separate set of heuristics or validation mechanics to to either authenticate or to validate the behavior separately. So, it's the policeman and the gate, right? So you've got 2 different mechanics, and having both as a shared trust entity singularly actually creates a bit of a weakness just in stepping back the structure. So at slice instantiation and through the health or monitoring, the visibility piece, however it is performed within that specific environment, I think would be a secondary control to deliver some degree of security and trust.
And I'm going to move you to an opposite direction. Okay, because we talk, all of us, with talks like to trust or not to trust, right? So are you thinking of using blockchain, zero trust, any of these methodologies, private blockchains? Again, this is all very interesting to us game theorists, but to what extent this technology is part of your portfolio? All right, cybernets and the like, okay, all that stuff. Are you using this into your security mechanisms? Do they have a role to play here? How much of a role? Are they useful, or they are just another myth to be broken?
So we're using blockchain in research for sure. We have several solutions. For the one that we're in the process of actually implementing is patch management. So when you have these continuous DevOps processes, to be able to use a private blockchain as a way to be able to test the integrity of the actual software that's being installed, because you see a violation, you want to actually build the blockchain trusted to update it. The second part of it is also, we've been thinking about looking at it from an IoT devices kind of perspective, but there again, the problem is the compute capabilities that these devices have. So what we have done there is actually look at almost like a trust score for certain classes of devices. And we do have a prototype platform that uses a blockchain framework to say that, okay, if you have this particular, simple device that's out there, a camera or whatever, it runs this particular operating system. You have all the characteristics of that device that is captured into your blockchain ledger that tells you now if there's any violation in that, any event that happened in that particular operating system that's running on this device, you will get an alert that you don't trust that device anymore, or the trust score has fallen beyond a certain acceptable threshold. And then you can go back and do an update. So again, a slicing is a good way to look at it, because you could have, let's say you think about hospital devices or something like that. You could have a slice where the device is on two slices. One slice that sends the data to the hospital, and a second slice that's actually the device manufacturer. So when the trust score goes down, instead of hindering the data collection process for the hospital, you will get a notification to the device vendor to say that, yes, you need to do an update because there was a blockchain indication that there was a trust score that went down. Now you can go back, upgrade your OS or whatever else needs to be fixed. Then it gets back to sending the data to the doctors. So it actually, slicing is a very useful tool to do a lot of these capabilities, and it actually helped security in that situation.
Anybody else on this topic, which is very much discussed nowadays? Like to trust or not to trust, zero trust or blockchains?
We're definitely applying zero trust architectures to our efforts, as I mentioned before, especially given that we have certain organizations that trust certain networks more than others, and as well as trying to look at that paradigm for how you build trust into the 5G network operations itself. But Mike, sorry, I cut you off before.
No, but I was just going to mention that we've certainly been supporting and working with operators for a number of years in their interests around this as they've looked to slicing, and blockchain. At its root, right, provides for absolute visibility to all transactions within the sequence. I mean, that's fundamentally, what it's providing, and that visibility, that knowledge of what's transpired, both preceding the transaction and, of course, providing that forward, gives folks then, or it gives the mechanics, right, and authentication mechanisms that visibility to the whole string to know if it's been tampered with, right? At the root of this all, to recognize whether there should or shouldn't be implicit trust, or if it's something that you permit for a period of time, giving flexibility to what is then provided over the service, over the access, over the time, right? Because there's so many factors that you can introduce, and slicing is awesome in its power, in that it's also not just a location in the environment or a type of access, but it's also for how long, right? So rather than this persistence concept that we've had as it's been entitlement for us for years in networking, these things can be instantly turned on and off according to needs, and all of those factors, along with the blockchain and knowledge of exactly what's requesting, why is it requested, who's it from, who's it to, that gives us the capability to support operator development of more advanced security services. And so there's a lot of promise, and certainly some exciting things that I can't share details about right here, but there are folks that are already pursuing this today in their build-outs.
Any other person? Any other questions? Because I have another difficult question. Anybody else has any questions? So the last question I want to ask you is, you didn't talk about the effects or consideration of human behavior in the network. If we start from the principle that, yeah, we are part of the network now as humans, whether we are driving a car or are we in a hospital or we are supervising a manufacturing line or we are in police or whatever, we're part of the network. So our behavior interpretation of what the network gives us and what we give back is important in the performance of the network, in the security of the network, and most importantly, and both Stu and Mike mentioned, in the speed of response. So how we tackle this issue? And in the same vein, to what extent more information is better or worse in these problems? I know it's not an easy question, but I mean, you have a lot more experience with me in actual situations, so I'd like to hear your views on this.
So, John, are you talking about human users of the network service or human users who are the network operators, or both?
Both.
Okay, so I have two thoughts there. So one very interesting research problem is trying to anticipate what human users will do next with the network, perhaps at the flow level, perhaps at the application level, and that has proven to be extraordinarily difficult. But taking back a step, there were some interesting papers, I think from Princeton a while back, that tried to take the SDN idea and extend it all the way to hosts, particularly hosts that produce a great deal of traffic, in an effort to try to anticipate, okay, what are those hosts going to do next? What are their requirements for the particular application they're using right now? And how can I best arrange and allocate my network resources to satisfy those demands? I think both of those areas are, I'm not sure where they will go from a research standpoint, but I think in both areas it's actually kind of intriguing, including intriguing from a game theoretic standpoint.
Anybody else? You all want to say something, so please do.
So, I mean, there's a number of elements here. If you pause for a moment to your human behavior aspect and think about how folks that are under 30 operate with regards to technologies and the inherent risks they're willing to take because it's just natural, it's water, right? So access to high-speed connections and their willingness to trust and to connect with folks just because it's the way in which they've worked for their entire lives versus, say, my folks, right, on the other end of the spectrum, and their adversity to, frankly, downloading or streaming technologies, much less willing to click through on a PDF or what have you. Security awareness training shifts, right? Network awareness, the ways in which we think about how to secure effectively the data sets that are being accessed. I think there are facets and factors here from a human philosophy perspective that are interesting. And when you pause to think about it, there's not that many technology vendors that consider it in this context broadly, right? And I've worked with well over 1,000 myself, in my prior roles, helping specify technologies. It's an interesting challenge, whether applied to the 5G slicing concept we've been discussing, or more broadly to the problems we're looking to solve for the next decade. I think we need to think about how the data is accessed and who's accessing what and where, and the logic we apply to that authentication, that trust mechanic is also considered. So it's.
So I have an interesting take on this, John, because I don't want people to have information about the network, right? I would like the network to be able to understand my intent and configure itself in a way that I can allow it to, achieve the intent that I had. I mean, we're already seeing that, right? So all the months before COVID, my iPhone would open up and say, it's time to go to work. It knows what time it is, what route I'm supposed to be taking. It's already planning the path for me to take on the roadways. So why wouldn't we expect the human to be able to just expect things to happen? I don't think that we're too far from that, right? But more realistically for today, if I think about it, if you look at an operator, they get a lot of data from the network. And if you go to the NOC, you see amazing amounts of data, but oftentimes they're all post-processed. There's very little live processing that's happening because of the complexity of the data that the network is throwing at you. But if you look at other systems like Netflix, for example, they're able to do things like Chaos Monkey that allows their operators to really insert failures, really understand the network live in real time, right? So one of the projects that we've been looking at, it's a research project right now for us that we've published some papers on, where we want to do is take sort of a snapshot of the network, and then put in the engineering rules that an operator would, a network operator would actually put in terms of their maintenance and what their what-if analysis are. But then after that, what we want to do is to be able to then allow the operator to inject things and provide the context. So what is missing today in the operator's environment is a huge amount of the context under which a particular failure happened is missing, because you're doing post-analysis. But if you can actually make that context awareness towards when the data is given, and you take the action rather than have all the data presented, just say which action was it that worked best for this context. And you're kind of simplifying the presentation of the data to the operator, but there's a lot of intelligence behind it that's actually doing that. So I would think of it as like a chaos monkey version for network operations, right?
Okay. I have one question. You said that the network should understand my intentions. And what if the intentions are adversarial? What if the intentions are not really genuine? How should the network handle that?
Yeah, it's a good question, because that's one of the most challenging things about those intent APIs that we are trying to define. And I don't think the security was ever considered. I mean, they talk about it, but not in a seriousness of like it should be considered. Because of course, if you make something work for somebody, you have to assume that there is an adversary that would actually, or an attacker that would leverage it. But so far, I would say it's still in the dream world of being able to make the network really adapt, but this intent concept has already started to happen. But how do you now authenticate the user to be able to place the intent to the network? And you would need to authenticate the user that's asking for that intent, whether they are even allowed. So I don't have slides to get into this detail, but we could talk offline if you want. But there are ways in which you would authenticate the intent to know what the scope of what they ask for the network. So you have TMF APIs that define the intent definition. You can then start to limit the scope of what a particular user based on an authentication is allowed to ask for from the network. Right. So there are some things, but it's not being standardized yet from a security perspective, but it's definitely something to consider.
Very good question, Tamer. And just for the audience, there is a subtopic in this whole area. It's called intent-based networking, which is very active. And it involves many of the things that you guys discussed, including the question that Professor Bazar asked. So I would like to thank you all very much, all four of you, for taking time of your busy schedules.
Thank you.
And thank you very much for the knowledge and information you gave us. And hopefully we'll be able to contact you in the future as we work in this area. So thank you very much. And now I want to move to the next section. Thank you.
Thank you very much.
Thank you.
Thanks.
Tamer, you have the floor.
Okay. Okay, so do you all see my slides?
Yes.
Okay, so now we have an exciting week and a normal 2-day GAMESEC was spread over 5 days with shorter days because of the virtual format, but I think it went extremely well. And again, this is the 11th conference on the series of GAMESEC. And first, we'll have a number of things in this closing session. But first, I want to send our kudos to John Barras and his team. And this is, of course, the first virtual mode that GAMESEC was held in. And I think it went extremely well, and I haven't detected any hitches or glitches, and this of course the John and his team on the program committee as well as in the organizing committee did a wonderful job, and Rada was also involved as general chair, and Kuan-Yan Su was involved, and we'll hear from him in a bit, was the TPC chair. But more importantly, I mean, the kudos go to the ground team of John Burroughs. They are at College Park, and they did an extremely good job in making sure that everything went smoothly. And this is, I think, will set the standard for any future virtual meetings that we may have. Who knows what will happen in the future and when we'll go back to normal life, when we can travel and and interact face to face. Now, let me share with you, those of you who don't know the history of GAMESEC. It all started in 2010, and that was a meeting. This was we organized it or initiated in Berlin, and Tansu was should be given all the credit. He was the brainchild, and he was at Deutsche Telekom in Berlin at the time, and under the auspices of Deutsche Telekom, this meeting was held. We thought that security was an important emerging field at the time, and game theory provided the perfect methodology for addressing several of the challenging problems. And the GAMESEC grew over the years, and the scope has expanded. And as you can see, the color code here is that the yellow stands for those meetings which were held in the US, and the white in Europe. So of the 11, 6 were held in the US and 5 in Europe. So the 12th one, well, we could expect it to go to Europe, and we'll have more on that shortly. And the scope has really grown over the years, and security is more important now, both at the level of countries as well as institutions, industry, government, and as well as individuals, as we have heard from the panel, as well as the talks that were given. So let me just in one slide summarize, at least from my perspective, what I saw at this meeting. There were the numbers were 30 presentations were made, and in addition to those, there were 2 keynotes and then the 2 panels, one by academicians, the other one by industry, which we just had. And the themes I have sort of, if I have to summarize them or compartmentalize them, definitely adversarial learning, machine learning is something which was not in the 10 years ago in GAMESEC, and now it's more a mainstream research area, which has entered definitely security. Deception was another theme that we have seen come across different presentations and papers. Games on graphs, security both at the hardware and software levels, the element of risk, security games, and also the security on social networks as well as in wireless networks were again other themes which were addressed by more than one paper. So a tradition of GAMESEC of the last several years is that there is a best paper award, and the TPC chair is in charge of seeing the process of selection as well as in announcing it. And So Kuan Yan, it's your turn now to announce the recipient of the Best Paper Award this year.
Okay, I'm here. No suspense, so I'm just going to announce the Best Paper Award. So this year's Best Paper Award is going to go to the authors of Exploiting Bounded Rationality in Risk-Based Cyber Camouflage Games by Omar Thakur, Shashin Jabari, and Pauri Agawao, Cleotilde Gonzalez, and Militan Bay, and Phoebe Wayanos. And congratulations to all the authors of the paper. And I think if I understand correctly, John, you can confirm later, we are going to send a certificate and a monetary award of $500 check to one of the authors who is going to send us their mailing address.
Yes, that's correct. Congratulations from all of us, from Radha, me, and Kuan Yan.
Congratulations to the recipients of the Best Paper Award. And again, as I indicated, we had so far 6 of the GAMESECs held in United States, and this is the second one in Maryland. Earlier we had it in Seattle, New York, Los Angeles, Fort Worth, Texas, and 5 of them in Europe: Berlin, Germany; Budapest, Hungary; London, England; and Vienna, Austria; and Stockholm, Sweden. And so now we are at the point where we'll have the announcement of the 12th GAMESEC. That's for next year. And Branislav Brano Bosanski will be announcing it. So Brano?
Yes, I'm here. Thank you very much. So can I?
Anything?
Yes, can I share the screen, please?
Okay, so let me stop my sharing, and then so now you can share your screen.
Okay, can you see the screen?
No, not.
Try again. Oh, so is it shared now?
So let's see.
No, we cannot see it.
Okay. That's strange. Why isn't it working? So let me try one more time.
You should be able to share.
Yes, just okay.
Okay,
now it's coming. Yes, we see it now.
Yeah. Okay. So thank you very much, and I apologize for technical problems. So it is my pleasure and great honor to welcome you in the next year in Prague. So the next GAMESEC 2021 will be in Prague. So you most likely all know where the Prague is located. We are in the heart of Europe, in Czech Republic, and we have a very nice castle, very nice old buildings, some new modern buildings, and we also have some very healthy food and beverage. So I think I will be more than happy to actually welcome all of you in person in Prague next year. I really sincerely hope that we will be able to meet. If not, if the pandemic situation will not be suitable for in-person meeting, then we will either prepare some hybrid mode or a virtual conference, and hopefully it will be as good as this year's conference. So thank you very much. I'm looking forward to next year GAMESEC. Hopefully we'll be able to prepare a very interesting program, and I'm looking forward to seeing all of you.
And it will be October 25, 26, and 27.
Yes.
October 25, 26, 27.
And 27, yes.
It's Monday, Tuesday, and Wednesday of October 2021.
Yes. Unless it's virtual, then of course it will spread over the entire week.
Yes, of course.
Yes. Very good. Thank you. Anna, looking forward to being in Prague next year. I have been there so many times, but it's always, every time it has been a refresher.
Right now it's empty. No one is here. So hopefully, I really hope that next year the life would go at least slightly back to normal.
Okay, so wonderful. And so the next on this in this closing session is I would like to invite John and Rada to provide some closing remarks.
Hello to everybody. Thank you for attending. I'll just be very brief. This was a really difficult and Herculean effort, and there are many people to thank. First and foremost, we would like to thank the authors of the papers that we went through various difficult situations and extensions, and I thank you for your persistence. And I want to thank the Herculean effort by Quang-Yan Zhu and the Technical Program Committee to review the articles and try to meet all the deadlines. We will keep shifting, and Springer for accepting our shifting times, and finally we finished the volume and everything went as we expected. Regarding publications and the volume, all the authors will receive a copy of the volume, and there will be some extras for invited speakers and keynotes and other people from the organizing committee. I would also like to thank Jutaon Chen for helping us a lot with the volume and with various communications with the authors, and Andrew Clark for a totally outstanding job on the webpage, again with additional things that we keep adding during the days. Of course, I want to thank Rada a lot for his immense help, especially with the keynotes. I want to thank the student assistants that they helped us. Special thanks to Adam and Marty, who are the technical support people that, like Tamer said, they kept the virtual conference, which we did for the first time, impeccable. There was no problem whatsoever. And I would like to thank the invited speakers, 7 of them, and the 2 keynotes for excellent presentations, and the panelists, both the academic people and the industry people. These sessions were both exciting and informative, and I hope all of us got something out of it for our future. Thank you all very much, and I'm looking for a successful continuation of the GAMESEC series. Rada, you may want to say a few things.
Yes, thank you, John. I think I want to acknowledge one person who has been at the core, which is John. Every time I think he works hard, next time he works harder, and it's relentless. And he has done quite a bit of groundwork, and he was part of all the activities, personally making sure that details of the AV and other things are in good shape. So thank you, John. The most important component of all this happening was the University of Maryland AV team. The entire team was fabulous. They anticipated details. They made sure there were no delays and glitches because of the technology side. Often it is us, the participants, and the rest of us who had some challenges. So thank you to the entire team, Adam and others. I also want to thank all the student volunteers who have done their part of the community engagement, and yeah, with that, the rest of the thank you again. I echo what John has mentioned for the keynote and the panelists and everybody else. Thank you very much. Again, thanks, John, and thanks, Tamir, and everyone else. And Kuan Yin also. Yeah, thank you.
Thanks, Radha, and thanks, John, for the outstanding work, and thanks to everyone who has contributed to this. It's a success story, and we'll be looking forward to next year's, and so see you all next year in Prague about the same time.
Thank you, Tamer. Thank you, everybody. Thank you.
Thank you. Bye now.
We'll try to post as many of the recordings as we can, provided we have an agreement with the people that spoke. Okay, so what's your email, and there will be an announcement as far as what we can post.
And it will be on the website also.
Yes, it will be on the website. And I'm also trying to get the presentations, actually the slides, from the invited speakers and the keynotes. Okay.
Yeah.
Those that they have, and the panels, both cases. Whoever wants to contribute, they will contribute, and we'll post it. So we'll keep you informed through Gentile as far as the via email, as far as what is hoping. Hopefully, we'll be able to finish for that within a week.
Yes, wonderful. Okay, have a good week. And
have a good week, and don't forget you have to vote next week. Okay.
That's right. Well, unless you have already voted. So these are the American citizens. Yeah, definitely. It's no time has been as crucial and important as this voting time.
Yeah, I have to remind you that that's a University of Maryland regulation. Sorry. Okay. Yeah. Have a good weekend, everybody, and thank you, everybody, and thanks, Tamer, again for starting you and Tansu this effort, which has become so successful. Thank you.
Great. Happy Friday. Thank you.
Thank you. Bye.